Yeah, it will take another 5 minutes. Please wait. Those who are joining online also, kindly wait for another 5 minutes.
Just stop it. So, fine with me. It's taking some time. Is it just put it in? Stream అవుతుందా?
Please take a seat. Good morning, everyone. Very much welcome to attend this seminar. This is our first attempt at IIT Hyderabad to conduct a seminar of this nature. The idea was that we will encourage interaction between our students and industry experts. So we have tried to bring in as many industry experts who have really made a name in their field, especially as a structural engineers, right? So majority of the audience we are expecting to be from structural engineering background, and I hope you will find this today's seminar useful. Okay. Just to quickly introduce myself, I am Dr. Anil Agrawal. I am a faculty at IIT Hyderabad. I specialize in the area of structural engineering, and I particularly my research interests are behavior of structures in fire conditions, high temperature conditions, steel, concrete, composites, and so on. Okay, so I will not take any more of your time. We'll start the session very soon. So let me first thank CTBUH for taking the initiative to organize this event at IIT Hyderabad and choosing IIT Hyderabad for this event. We are very much thankful to you, sir, and for taking this initiative and making all the effort to invite all the speakers. We are only taking care of the local logistics, but they have put in a lot of effort. So thank you to them and welcome to all of you again. Let me first start with the welcoming all the speakers who have agreed to present today and talk about the areas of work that they do. So let me start with inviting Mr. Amitabh Kumar. He is also representing CTBUH here. Please come in, sir. This they will just, you can give it to him. Wait for the picture, please. Thank you. Yeah. Thank you. Yeah, please. Let me invite Mr. Jay Shah for taking time out, and yeah, so another bouquet, please. Thank you, Mr. Shah, for taking time out to join us. Okay. Let me invite Mr. Gautam Bhasin also for. Oh, he has taken out. Okay. So let me invite Mr. Jagdish Babu in that case. Yeah, please. Yeah. Thank you. So maybe we will get back to Mr. Bhasin in a minute. So he will come back in a minute. You keep it here. He will come back in a minute, the other speaker. My audio is okay, right? Yes, sir. Okay. So thank you. One request to all of you, please put your mobile phones in silent mode or switch them off so that we don't disturb. Also, the live streaming is going on in YouTube. So I would request all the speakers, when the questions are asked, the speakers may repeat the question because YouTube audience will not get to hear the questions. So during the question answer session, if the speakers repeat the question, it will be helpful for the audience online. Okay, thank you. So with that, let us start with our national anthem first. Request the organizer to please play the national anthem. It's on the speaker. Yes.
शुभ आशीष
Please take your seats. Okay, open the introduction to Mr. Amitabh Kumar. Yeah. So now we will start our session. So in the very beginning, we would want to give you an introduction of what CTBUH is, what are the different activities they are indulging in. There is a book display also outside this building. You are encouraged to take a look at those books and buy them if you find them interesting. So to start with, let me invite Mr. Amitabh Kumar. He is one of the prominent speakers today. I'll quickly introduce him, sir. So Mr. Amitabh Kumar is currently the director of Project Matrix LLP. He has more than 34 years of experience as a structural engineer and project manager. He has received a certification of expertise in project management from the University of Toronto. Earlier, he did his BTech from NIT Allahabad and MTech from IIT Kanpur. He has been instrumental and actively contributed to the design and construction of 250 meters plus high-rise buildings, including the Sky Tower, Indiabulls Sky Tower, and K. Raheja Tower in Mumbai, right? So he has vast experience, and he is spearheading the efforts at CTBUH end, and I'm very happy to invite you, sir. So please, you may introduce. So, thank you. The first presentation.
Put in the pocket. Your bag. Pocket. Yes. Just right here, right here, left side. Focus. ये focus. Red वाला. ये focus है. ये right, ये left.
Okay. Thank you. Thanks to Anil ji for a nice introduction. Thank you IIT Hyderabad for hosting this event and taking all the efforts by Anil ji. Without his support, this seminar would not have happened. Thanks to all of you who has come for this seminar, all the students, faculty, and the local Hyderabad construction industry people, consultants. All of you are thankful. We are thankful to all of you for gracing this occasion. I would like to first tell me, some of you might be aware, some of you may not be aware about the CTBUH, so Council on Tall Building and how to go? Acha, I will do from here. Yeah, I will do from. Can you help me with that? Just
a second.
So I have to keep on entering.
You can use this.
How?
Just a second. This is the right one.
So this will be what? Yeah. So about CTBUH. CTBUH is international body. It's a non-for-profit organization. It is based in out of Illinois Institute of Technology, Chicago, and it is working worldwide for dissemination of knowledge and all aspects of tall building. Not only the structural aspects, not only the design, construction, also the developers, even the users of the tall building are represented in CTBUH. So CTBUH is a wide body which take care of all those things. CTBUH is the arbitrator to decide 20 tallest, 10 tallest skyscrapers of the world. So many laymen knows CTBUH only due to those what are the tallest building, 10 tallest, 20 tallest, like that. CTBUH India, so CTBUH is having many chapters, almost 45 countries in the world having CTBUH chapters. CTBUH India started in 2015 as an Indian chapter, and we are doing works on our own for dissemination of tall building knowledge and other things. So CTBUH vision and mission, global real estate world connect, research and data, funded award programs, then students also, students competition hold with every year, and students from all over the world can participate in that competition. CTBUH also gives annual award for best tall building of the year every year. Now it is award and conference has been put together. Previously it used to be separate. So global interchange, these are the themes of different conferences like 2015 global interchange, mega cities, connecting the city, polycentric cities 2018 conference, then 50 forward 50 back was when the CTBUH completed its 50 years. So this happened in Chicago. And this was the recent conference, whole last conference in Singapore, humanizing high density in 2023, Singapore and Kuala Lumpur. CTBUH India collaborates. It's an academic chapter. We collaborate with academics, we collaborate with developers, we collaborate with designers, and with all that we work. We also, CTBUH India signed MOU with D.Y. Patil University. We are going to other universities also. We are having a MOU with IGBC for green building and ISRE for fire and fire safety. So these are the people, executive committee members. So Girish Dravid gives this introduction, but since CTBUH Girish Dravid is not here, so this responsibility has fallen on me to introduce to all of you about the CTBUH. Anil Hira is active. These are the executive committee. There are the many more people. Gautam is here who help us in doing different activities of CTBUH. There are patrons and knowledge partners who help us in this endeavor. Now the CTBUH has become big, CTBUH International, and they have different hubs. So there is Asia hub, there is Europe, then America hub, and Australia. So Asia hub from India, myself and Mr. Rishikesh is representing in CTBUH Asia hub as a steering committee member. We have completed 9 years, CTBUH India. So just I will give you some glimpses what we do. So we like draft code, technical discussion, CTBUH India in 2015, wind, earthquake. K. Suresh Kumar was a speaker for wind engineering, and different conferences, seminars we do. Fire and Security Association of India, in collaboration with them, we have done some talks and seminars. This is a very important and very popular by CTBUH India and CTBUH International. So CTBUH International holds a walk tour of different tall buildings or different regions in a city on a fixed date all over the world with a theme. Sometimes it's a walk on the water, sometimes other. So Bombay to Mumbai was the walk for 2018. We are going to hold the CTBUH walk on 3rd of this February at Mumbai, which will cover the metro constructions, and people will be taken through the tunnels of those. So all over the world, almost most participations happens in CTBUH India walk. We are having almost 200, more than 200 plus people walking for that. These are the students interaction session in D.Y. Patil, when was curated by these people on the subjects. This we hold a seminar for parking system and technology in Mumbai. This was on human health and the built environment for the buildings. So we are not particularly in one topic, we are covering all the aspects of tall buildings. CTBUH 2022 International Conference happened at Chicago. This is a picture of CTBUH India WA 2023. The patrons meet. So there is a student research competition I was doing. So every conference, students can send their entry to the CTBUH with their ideas. So one entry was sent last year, and CTBUH India has encouraged their students and patronized them to do so. These are the different functions pictures. Future of high-rise, sustainable water management. So recently, Sean Mills, the director of CTBUH International, came. This was the 19th of January, we completed this seminar. It was on a transit-oriented development for sustainable urban habitat in Mumbai. And this is the seminar which we are attending. Thank you. Thank you to all of you.
Thank you, Mr. Amitabh Kumar, for introducing CTBUH to us. Let me now invite the first speaker, first technical speaker, Mr. Jay Shah. Mr. Jay Shah is the director at Access Architects. He is recognized for his commitment to design excellence, and he is here to give us an architect's perspective, because most of the audience here is structural engineers. Mr. Shah has completed his Bachelor of Architecture from KRVIA, Mumbai, and he has a Master's in Advanced Architecture Design from Columbia University, New York. He has worked in New York after a while, and then he came back to India, and now he is heading he's the director at Access Architects. So the floor is yours, sir.
Thank you.
Presentation is about 40 minutes. At around 35 minutes, I will wave to you, so then you can wrap in 5 minutes, and then another 5 minutes for questions.
Done. Does that work?
This is PDF, so you may have to...
Okay, perfect. Hi, everyone. So the initial thought process was so the intent was to talk about 10 crucial learnings from an architect to future engineers. To tell you a little bit, you got a bit of an introduction, but specifically because it's a seminar for tall buildings, a little bit about some of the work that we've done. So the buildings in blue are the buildings that are designed and completed by our company in Mumbai. Some highlights being the tallest completed commercial building in South Asia. I mean, quite a few of interesting buildings. We recently acquired an architectural firm from Paris and Bangkok, and I think that's the first of its kind. Our design director is a Frenchman sitting out of the Paris office. The Sofitel in New York, the St. Regis in St. Regis Residences in Bangkok, as well as the W in Sanya Along, China, all are designed by us, aside from about 500 other projects. To get to the point, what we were originally going to talk about was in one slide which was, what can an architect actually bring to the table and talk to future engineers. And I believe most of you all are already graduated, so engineers already. And I think while it would have been nice to do that, the more I thought about it, I felt this is something which you can probably Google and find out a little bit more. Maybe if I can talk a little bit more that is possibly more relevant to what we're here for today. So what one felt to be particularly interesting, and what I think is something which people coming into the field in the next few years will become particularly important is technology and our relationship to technology. I'll take a little bit of a detour and talk about that rather than anything else. What I mean by technology is, of course, we'll watch a cool movie. Anyone who's a fan of Avengers? Which is your favorite Avenger? You know, funny thing is, everyone says that. For me too. I love the Avengers. So I think this is a very interesting thing about the Iron Man, right? If you think about the Iron Man, he's part human, part AI, part technology. And I think that says a lot about what our relationship to technology should be. So I'll take you through a few projects that we've done, and I'll kind of come back to, you know, how does one really use technology in a way that is most applicable, especially now as it's going to have more and more impact in the future. So this is actually a project that we've been involved in where it's about 7 million square feet, high-rise project, extremely dense project, an FAR of about 15, which means extremely dense. In the center of Mumbai, Mr. Amitabh Kumar here is actually involved as project manager on this project. And to give you a little background, because of government regulations, etc., what you are left with is the footprint of the building is basically the entire open area that you are left with. There is very little open area that you actually have ability of doing, and more as the cities become denser, we start seeing, you know, we talk about CTBUH, we start seeing that the tall buildings are coming up, but the open spaces aren't really being found because density is growing. So, you know, interesting building from a structural perspective, nice strong core, small columns, etc. But for us, you know, what we really felt was, from an architectural perspective, how do we solve the baseline issue of the fact that there really isn't open space for people to enjoy. So what we've done here is, what you see in terms of the parking footprint at the bottom is actually the entire site that is available. This is a 200-meter building, which is about, and at 180 meters, we have designed a 100-foot cantilever. Now, what is the reason for that? The idea here is, when one looks at the building, the fact that it's devoid of really the sky or the open space, what one has done is created an entire zone which happens at 180 meters, where one is able to enjoy, you know, the kind of living that we would ideally want, and to be able to enjoy the view. The other advantage is that one is able to have housing that actually peers over, so it's kind of, you have villas in the sky, to be able to apply to that. Now, it's always great as an architect, it's good to kind of imagine these things. Obviously, this is not feasible unless we have engineers who are actually able to execute this. And that's where I think it was particularly nice as a collaboration, because we were almost, you know, hesitating that, you know, it's a 30-meter cantilever at 180 meters, you know, this is going to get really difficult. And, you know, the engineering team on this project actually pushed us, saying, no, that's, you want to make it 33, you want to make it 35? Should be doable. Which, you know, it tells us a lot, because, you know, as we kind of speak more and more to multiple engineers across multiple projects, you tend to come across these two different things where, you know, one engineer is trying to be conservative, trying to kind of, you know, let's stay within safety, why are we trying to do this? And then you come across a team which really is pushing the boundary and pushing the envelope, saying, you know, there is an idea, there's an intent, that intent is worthwhile, why don't we find a way to actually get this to work? And we've since actually developed the entire system in terms of the structural system, including the plans, etc. And you know, this is what I would say from a construction technology perspective, from an engineering perspective, something really interesting, because obviously from a budgeting, etc. perspective, it made sense to do the building in concrete. This, of course, needs to be in steel. So the idea is, how do you merge the two, especially at that height? How do you shutter this, etc.? It's been an incredible experience. And coming back to when one works, it's always team, right? When an architect works with an engineer, it's always good when an engineer comes across being more open to kind of ideas, etc., etc. We'll take a pretty hard right turn with digital technology. So we are actually InQB partners with Google out of New York. And they have this artificial intelligence platform called Delve. And I'm going to spend a little more time on artificial intelligence today specifically. What Delve basically does is you tell it what is the site. So there's a particularly interesting site we're working on right on the shore of Mumbai, 30,000 square meters in the center of Mumbai, extremely premium site. What this platform does is on Google Earth, you mark out the site. You mention we want to do a hotel, we want to do residential, we want to do commercial, etc. These are the areas we want to do. In 3 minutes, it generates multiple design options with entire budgeting. Think about what the technology is doing for us. And as an architect, I have to be mindful. As an engineer, you just have to be mindful of what technology will continue progressing while we're still at the same place. What I have spent my life doing, this software is looking to do in 3 minutes. We've been working with Google actually pretty closely for the last year and a half, and one can see the improvement in the AI backend, and to the point where we've actually used it on multiple projects in India. So on this project specifically, it was again a particularly dense development, as every development in Mumbai is, where we're doing 240-meter towers, and the idea here is, from a fitment perspective, feasible perspective, honestly, you get a lot of interesting ideas from the platform. And it allowed us to start really spending time on the design aspects beyond the practical aspects. And here is again an interesting way to partner with technology where, yes, it does a whole bunch of things incredibly well. How do we take that 2 steps further? How do we do better than we were able to do yesterday, rather than being worried about AI taking our jobs? And this is what we ended up doing. And typically we're doing a 3-tower, 250-meter tower. So we would do something interesting from for the residential unit perspective, maybe pushing it a little bit further. Here we said, again, what does it actually take to push this beyond? So there was an understanding of, while we need these towers, can we start doing these bridges where we really create houses in the sky or mansions in the sky? Because one of the advantages that we used to have once upon a time is that you could really live on the ground. You could live as if you had a veranda, etc. That's going away very quickly. And so here the idea was, can we actually take that up, and and this is something which has been done before. It's basically bridge elements across 2 towers. This is not something that's really novel. But we said, let's push it a little bit further. So this is what we've actually designed, where the intent is we take gardens in the sky, and the thought process, the greenery actually rises up along the building. From an engineering perspective, again, while it is challenging, it's actually a little bit easier because these are mostly bridge elements. These are not particularly cantilevered elements. There are challenges attached to it, no doubt. But, it allows us to imagine a future that maybe we wouldn't have imagined earlier. Also, it allows us to actually extend ourselves where we're spending time on areas which we earlier did not spend time in within a particular footprint. So, you have this incredibly futuristic AI background, and with that you go back to the old school, but what is it that somebody actually wants in their living quarters? How does one actually build this? Can this actually be a feasible? So you have a beautiful promenade with a hotel, a commercial building, a nice mixed-use development that actually would hopefully be a nice place to live as it gets built. And ambition is always a good thing, because you are, one of the other things I have learned is that we always think about cost, and it's a very common thing, right? Something's too costly. When we think about it, a civil cost increase is only going to be marginal. Us putting Italian marble in a house is always going to be a comparatively much higher cost. So think about it, right? My civil cost might go 500 rupees a square foot higher when I'm doing something crazy. I could very easily put Italian marble of 500 rupees a square foot in my interior spaces. So it's also recognizing there is a cost element to it, there's no doubt about it. In some cases you have more flexibility than others. But it's interesting about, one, there is an idea, and how does one actually get to that idea while staying within the constraints of engineering challenges, cost, etc., etc. And it was a pretty interesting sort of back and forth between what Google is doing and what we're doing, and it obviously is a project that continues as we sort of move. This is actually an AI platform founded by us. So this is my background is way back in 2008. I actually did my master's with a specialization in artificial intelligence. So back then nobody really knew, I didn't really know, but I had this professor who was talking all these crazy things, felt he was crazy. He turned out to be one of the smartest people I've ever met. And here in about 2018 realized that there is a place where we could use that in the real world scenario to actually improve optimization, to optimize, because what you're basically doing is that you are running multiple iterations on a baseline. And the idea here is you're not actually trying to replace the human mind. So in this case, what we are saying is that there's a lot of things that come in from a manual process. So we let that have its say. At schematic, we actually run this through the platform and we start looking at what are the optimizations that we could possibly do on the project. So the idea is that you're able to run multiple iterations within limitations. So in 7 days, on this project within these limitations, what is the difference that one could make? It has allowed us to, we've done this actually over 145 projects, but it typically takes us about a week to be able to run this and give initial results. What we would otherwise, the design process usually obviously takes 6 months, 8 months. Here our entire exercise takes about a month. Let me give you a couple of examples of where we've actually used it. So there's a project in Dubai actually, where we typically like coming in at schematic, where there is flexibility in terms of what changes we can recommend. This is a particularly challenging project because the building was actually about to start construction. We had already, approvals were done, sales were done, everything was done. And then, client came in and listened, is there any optimization that we could do? But we couldn't really change anything. We couldn't change any apartment floor plan. We could not change any slab outlines. There's really nothing we could do. So we said, what is the optimization we're really thinking about? And, one of the things we started realizing, which is something which all structural engineers hate, is there are a whole bunch of transfers, because you're doing retail, you're doing parking, you're doing offices, and you're doing residential. So we had a whole bunch of these transfers that actually happened across the building. All of them being because of about a 40-story building, you had 3-meter deep transfer girders that were actually happening at multiple levels in the building. Now think about it, you are doing transfer for about 35, 38 stories. It's not ideal, it's extremely expensive, it's time consuming, it's not sustainable. But apartments are sold, cannot change apartment layouts, cannot change slab outlines. We were able to resolve the layouts in such a way where we entirely eliminated structural transfers on the project. So think about the value of that, where it saved about 18 million dirhams which is a decent amount of money. And what did one have to do? You're not touching the apartment levels, which is already sold. You're not touching the retail levels. You're basically changing the thing that you can change, which is the parking. If you're able to fit in the same number of car parks without doing all of that, that's huge. So it tells us a little bit about what obviously this can do. Now pushing that a couple of steps further, this is a commercial building in Mumbai, and the Marriott Executive Apartments and IT block. A lot of these blocks coming up in Hyderabad, so I thought it might be quite relevant. This is a typical floor plan that was generated, 132 meters, 7.5 meter span. Here, this is New Bombay, so cost was a major challenge. So, the client was not doing PT, was looking at doing regular concrete. From a design perspective, etc., it obviously is not ideal. One of the things we realize is that there is a real value in looking at composite steel, and you'll hear a lot more about that as this day progresses, especially for office buildings. But here what we actually were able to do is optimize an RCC option and a steel option for the same height. You are able to see the area lost in structure going from 102.5 to 65.67 to 45.22. Now, what is it that you are creating a building for? You're creating it for tenants. If you are reducing your column sizes, are you able to fit more tenants in? Is it more flexible for people to work in that space? If you are, doesn't that make sense to actually start looking at it more seriously? So, if you look at, obviously from a typical floor perspective, if one is able to optimize for number of staircases, if one is able to optimize for column sizes, same slab outline, we went from 170 car parks to 270 car parks. So, it's really interesting. There's obviously the human endeavor, but for the same building as we completed, we did the building in 27 months instead of the expected 60 months. So the building got done faster. Lease only building, your revenue starts coming in earlier. Within the same FAR, we were able to increase the leasable area by almost 15%, while actually reducing the constructed area by about 12%. If you start putting numbers to this, we're talking about hundreds of crores. So we've obviously been doing a whole bunch of other projects in that area, but it tells us about crores. So do is run multiple iterations within limitations and parameters to be able to optimize across 10,000, 20,000 iterations. Now look at what the technology is bringing to you, right? Because you are kind of trying to combine artificial intelligence and human intelligence. When you are constructing 10%, 12% less area, you are using that 10 to 12% less material. You are electrifying 10 to 12% less, because most of this area that's reduced is actually common areas or parking areas, not your revenue generating areas. So think about the long-term impact from a sustainability perspective when one is able to optimize to this level. And it's a merger of the human thought process, the human design process, and using AI along with it. So we've been doing this in Miami, Dubai, Saudi Arabia, all over the place. We've done about 145 projects with a tangible value increase about $4.5 billion US. I've been doing with L&T Realty, Prestige, Godrej Properties, etc., etc. That's in Malaysia. But I just want to end with, where we started, which was the rather boring, what are the learnings from an architect, and hopefully this was helpful. You can read through these later, but one of the things that AI can do interestingly well, I don't know if you guys have come across this, if you put up a selfie, just a single selfie on some of these AI platforms, they actually come back with profile photographs where you've not gone to a photographer, you've not done the lighting, you've not spent any money on any of that, you're sitting at your house and you're getting profile photos clicked. And when you did it the first time, you realized, you know what, I don't really have two hands and I don't really look anything like this. Sorry, three hands. And you realize, this is probably not all that it's, people are talking about AI taking over the world. No, it doesn't really work the way you are sort of expected. And that's when you come back to this idea of Iron Man, right? That it's not AI, it's what you prompt in, it's what you put in. And so then you kind of use some prompts, you try, maybe there's a better way of doing it. And I don't look as good as this. But it looks quite good. So, I said, let's spend a little more time on this. And the interesting thing is, now the profile image that I usually send when I send all these seminars, actually is just generated by AI. Because the one that my photographer clicked was much older and didn't look as nice. So it's really interesting about coming back to our relationship with technology and thinking of this as the incredible change that's happening, and I'm specific to AI right now, that's happening in the world today. And I tell every intern and every junior architect that enters our office that if you've not played around with it, it's really sad because you have no idea the impact this will have less than 5 years from now. The way we run our practices, the way we run our offices, the way we do our projects will change forever. And I'm telling you this because also I have some background of what's going on at Google, etc. So this is one thing which I want to say, that one, don't be scared of what it will do to the profession. Think of what artificial intelligence and human intelligence will do together, and how can you take advantage of that. Thank you.
Keep the mic with you.
Oh yeah, sorry. Yeah.
So we have time for questions. Any questions from the audience? Raise your hand.
How really you are modifying the so if you are first having the architects design
Sure.
for a particular project,
Sure.
and then how is your guys in AI, you are putting a big model, or are you directly taking this Kaizen into the BIM environment and doing the...
No, it's the same thing, right?
Can you repeat the question?
Yeah, so the question, if I understood correctly, is how does it work in terms of how does it actually interact with what is already existing? So in fact, exactly what you said, you build a BIM model and you run it through the platform. Of course, we've figured out certain parameters to measure for, which have been particularly successful in finding these opportunities for optimization. But in essence, our input is very much a BIM model. Thanks.
So, conservation of resources as well as the time is the most important for any work. So, certainly, why not you publish some paper or some kind of standard to come up with innovative solutions and everything? It will be good for India as well as
one of the reasons I'm talking to everybody today is to spread the word. And
what you said is
Sure.
27 months construction period,
Sure.
16 months, that makes a lot of difference. You know what will be the saving in ITC and other things, and that also some 12% or 13% increase in the floor area and other things. It's excellent.
happy to do that. Actually, someone who's going to speak today, Mr. Jagdish Babu, has actually been doing this in Hyderabad more than anybody else. So you'll actually hear from him where he's been actually pioneering steel composite construction for commercial buildings. Happy to sort of work together to spread the word. It's something which I think more and more people should know about and recognize the opportunity that exists, for sure.
Let us ask one more question. So
Sure.
when you are introducing very strong elements, steel elements, along with the concrete elements. There will be stress concentrations and high stress zones are there. How you are treating that stress zones?
So do you mean in terms of loading?
No.
In terms of between the relationship between the concrete and the steel? I'm going to let the engineers talk about that rather than me talking about it, because I will mess up the answer.
One of my friends has called around 3-4 months back and he was doing some same kind of drilling need. And some during the near the openings he found some high intensity stresses and everything. Somehow they introduced some steel plate or something like that. So that kind of situations would be more if you go for a composite kind of.
I was just going to say that one of the other things, and one of the reasons I do like speaking about this is because we do see a certain resistance or in terms of adopting steel or steel composite construction in general, because I believe maybe the information out there is not as high. Even when we're selecting structural consultants, etc., for the project, we are very careful because sometimes that does have a major impact. But you're absolutely right. You've got two people who are masters in the field, so you'll hear more about it today.
Okay, I think maybe my question is related to what is already asked. You mentioned that AI and so on is coming into architectural aspects. Now, do you think the construction industry is able to match up or pace with the architectural thing? The reason I'm asking is, in this campus, for example, we have a sports complex, which is again architecture by Japanese theme. And it's a very peculiar roof. And I understand that there was a lot of efforts to make that particular shape, even by one of the top contractors. So, the question is the industry, construction industry, keeping pace with the architecture that you are looking for?
So I actually interestingly see that as a massive opportunity, because you are absolutely right. The construction industry generally have been laggards in terms of technology. Today you just can't afford to be. So I do see, and of course we spend some time with L&T, etc., who are really trying to push the envelope in terms of technology usage. But there is huge opportunity for a newer player to come in, because that's another interesting thing that has happened, that a lot of these tools are actually not the domain of the big boy. These tools are often available to anybody and everybody to use, including students. Creating tessellations, finding simpler methodologies of doing complex shapes. All of these things are actually out there where you don't need a supercomputer anymore, you don't need really special knowledge. So I see this as a huge opportunity for actually also the newer guys to come in for more niche projects, right? So for example, if someone's doing a bridge and someone's doing massive work, yes, there is a certain background needed, a certain capital, etc. needed. But if, like exactly what you said, if one wanted to find a way to optimize a roof structure in a way that it's most cost effective, you actually need very little. You just need to understand where to go to get the right answer. And I think that presents an incredible opportunity for the guys who are coming into the industry soon.
Any other questions? Yeah, please go ahead.
Hi sir, I'm Architect Roy from RJ Associates. So my question is going to be a little off bit. Does this AI Kaizen knows about Vastu structure, because
Sure.
in South India and in Hyderabad,
That's very important.
The residential buildings, we have so many other buildings like hospitals and hostels and some government offices. So we are stuck with the Vastu considerations. So does this technology overcome the Vastu?
Sure. So two things. Great to see another architect in the audience. I thought I was the only one. So, two things attached to that. So The way the model works is that you basically train it, or you set parameters to be able to do something. We've currently not tested for Vastu, the reason being typically we are an optimization platform where we don't look at it for design. There is a design that's already done. If there are opportunities for improvement, it could possibly do. But currently we've not actually, tried doing it. At the same time, I should say, like we're currently talking about doing a high-rise jail in Manhattan. Like we've never done that also before, but it's one of those things where if one spends enough time on it, it's something that is feasible. But today it's not there. I don't see a reason why it can't be there. It's just that today we have not spent time on that direction.
It's a good business idea, Jay.
I was saying it might be free for you.
Vastu for Hyderabad.
So one other question related to that, exactly on the Vastu, but then architecture primarily, whenever you design, you look at climatology as a perspective of that. When I see a lot of buildings when it is designed, overlaps, cantilevers which gets in, the amount of shadow which gets in is not actually allowing the sunlight directly to fall in where it is actually.
Very true.
So do you actually feed or make your software validate that and ensure that those things are taken care of, and that is something which...
Sure. So interestingly, there's a tool that, Delph, the Google software I showed you, actually does that specifically, where it really talks about, how sunpath. So that's another interesting thing where, we are currently, at least on the technology front, everybody kind of has figured out something and does some things really well. So if I wanted to do that, I would just use something that's already available rather than build it. But it's there today. You can use it today. So a lot of these things are things which it's just people don't know about it, and the only way of knowing about it is going out and trying things. But I think this is something which is available more and more, and it's something which is doable.
All right, thank you for wonderful questions, and thank you for patiently answering all of them.
Thank you.
Yeah, so let us move to the next session, but before we do, Mr. Basim is here now, so let us formally welcome him, with a bouquet. Yeah. Let us, with a big... Thank you for joining us, and thank you for participating in this one. Thank you. Please take a seat. So now we will move to the next talk. Can you open the intro bio again, or just the presentation? I think email presentation. Yeah. So let me invite our second speaker. You are already familiar with Mr. Amitabh Kumar. Just to briefly introduce to those who have joined after the initial introduction. Mr. Amitabh Kumar is currently the director of Proj Matrix LLP. He has a vast experience of 34 plus years in the area of structural engineering and MCP. And he has a BTech and MTech from NIT Allahabad and MTech from IIT Kanpur. And he has been instrumental in the development of these very, very tall towers in Mumbai, including the India Bulls Sky Towers and K. Raheja Artesia Tower in Mumbai, which are 250 stories, meters plus tall towers. So, Mr. Amitabh Kumar, thank you.
Thank you.
Hi, good morning to all of you. I am again here. So it was a very interesting session. I must congratulate Jay for introducing us to his AI ideas, and we are working together for many projects, and it's a very challenging thing. This topic will be a quite, sorry?
Hopefully not working with this.
No, it's very challenging. challenging aspect of engineering, and he is pushing us to 100 meter, 110 meter of cantilever, which he told, and then he told me no, at the top it will be more than that. So because it's an inclined shape, so we will get 120 meter, 118 meter at the top. So he pushed us to come to his vision. That's okay. So why I am reminding his talk, because you will be find it a boring, because construction and structures is much boring than architecture. So please bear with me. I have chosen this topic. My topic is outrigger and damper in tall buildings. I have purposely chosen this topic because many people are not aware of concept of outriggers and dampers in the actual construction, unless you have worked on tall buildings like 250 meter, 300 meter, like so. So what we will learn? We will discuss outrigger and belt truss concepts, then optimal location of outrigger on a building, both plan and elevation, outrigger systems on tall building. I will give you some examples, live examples of the outriggers, so that you can understand some aspects about outrigger construction, dampers for tall building, and if time permits, I will go to the design considerations. I will rush through some slides because time doesn't permit me to give you all the 56 slides, and then there are 3 slides where I have taken the references from different books and journals. So let us start with the outrigger concept. So all of us know tall building is just cantilevering out of the earth, and it is witnessing lateral loads. So lateral loads are most important. Lateral load resisting system for a tall building is the most important part. Gravity load is okay, the structure can take. So wind and seismic loads are coming on this, and then building has to be take care of shear resistance, it has to be take care of bending resistance, it should not overturn. And please mind that for tall buildings, generally the wind load is governing. Wind is much more than your seismic load. So most of the tall buildings, if you are exceeding about 140 meter, 150 meter, then mostly this wind load will be governing. So let us start with the outrigger concept. So what is the outrigger? So outrigger have been used in tall buildings for about 50 years now, 50, 60 years, half a century. This is the example of the oldest outrigger system. So if you see the canoe, narrow hull-shaped boats, they are ocean-going boats. So what they did, they try to overturn the choppy sea. So what they do, they just put a extension, and this is called outrigger. So outrigger words come from here, not from the building. So what it does, when this try to overturn due to the choppy sea, so if it is overturning, weight of this will try to restore the moment. Similarly, if it is going in the other direction, then the flotation will act. So they will try to avoid overturning, and that way it will be more stable. So similarly, in buildings, what outrigger is connected to the perimeter columns, resisting upward and downward forces, can improve the bending overturning resistance of the building. This is a typical tall building. So this is a core, maybe in truss or maybe in concrete. These are the outriggers at different floors. So outrigger is connecting the core to the perimeter columns, exterior columns. And this is an example of an offset core, where there is only core is offset in one direction. So we have the not in the central core, and then we have outriggers connected to the peripheral columns. So let us understand this slide this is the structural core. This is just representing an RCC building. This is a structural core. These are the two level of outriggers connecting this structural core to the perimeter column. So suppose if a wind is trying to come from this direction, it is overturning, then what will happen? See, this outrigger all your lewards column will be in compression, and your these columns, windward columns, will be in tension. So what will happen? There will be an opposite reaction force from the column, and this P force multiplied by this lever arm, which is large, it will create it will just resist this overturning moment in this direction. So if you see this diagram, had there been no outrigger, you would have obtained this bending moment diagram, and base moment would have been from here to here. But once the outrigger is at this level, so this restoring moment has reduced this, and it has come to this. If you come to the outrigger level, middle outrigger level, then it has been further reduced, and third outrigger level, it is reduced. So final base moment is much less what would have been without the outrigger. So this is the basic concept of outrigger. So moment in core with outrigger bracing reduces the base moment. Once the base moment is reduced, there are so many advantages. Your steel is reduced, and you are having uniform pressure on your foundation, and all such things. But this is the very basic concept. So now we can define the outriggers. So outriggers are rigid horizontal structures. Why it should be rigid? Because if you it has to develop the forces. Let me go back. Okay. So outriggers are rigid horizontal structures. They are designed to improve building overturning stiffness and strength by connecting the building core to the perimeter columns. Okay. So belt truss is often used with the outrigger because outrigger is only connected from the core to the one particular column, but there are many other peripheral columns also. So for those peripheral columns, it will be difficult to mobilize the forces unless we encircle it with a belt truss. So belt truss, in addition to the column directly connected to the core through the outrigger, also gives you advantage of other columns. So belt truss is often used along with the outrigger. So belt truss, core and outrigger is a system of resisting the lateral overturning moment, lateral forces in building with outriggers. So they have to be very rigid. So how we can make it rigid? So generally in real life they will go 1 story, sometimes 2 story, even 3 story high. So once your depth is high, you get your 1/12 BDQ, so your I will be high and the stiffness will be high because the depth is more. Oh, it's not back. Sorry. Right. So what are the benefits of outrigger system? Just be here. So what is the benefit of outrigger system? So it reduces the building deformation by reducing the overturning moment. We have seen in the previous slide. So for tall buildings, generally it can reduce overturning moment up to 50%. For super tall buildings, so CTBUS defines super tall, more than 300 meter tall is super tall, 600 meter tall is mega tall. So for super tall building, you can get up to 60% reduction in base overturning moment. It will also reduce forces in core foundations. It will have an effect of reducing your wind-induced oscillations, which is very important for human comfort. I will discuss that in detail afterwards. It will give a structurally efficient building. You are putting the material where it is required. You are putting the material at the perimeter of the column, and you are taking care of the large cantilever is helping you, giving that overturning moment with the less use of material at the column, perimeter column. So it is an efficient way of reducing the overturning moment, taking care of the, taking use of the large L of this outrigger system. And if your building is torsional, there is having torsional stiffness in building. If your building is irregular, generally we get the torsional irregularity and torsion is more. So in that cases, belt truss will help you in stabilizing the building for torsional stiffness. Of course, it is giving you more collapse resistance because we are making alternate load paths through the belt trussage. So suppose if one of the column has failed in a critical condition, then belt truss is connecting other columns. So if one column has failed, the belt truss upper columns will take load will be distributed to the other columns which is connected to belt truss. Next. Yeah. Next slide, please. Yeah. No, you have gone to the one slide. Yes. No. It is skipping 2 slides. Yeah. So this is showing you a general. Sorry, my mistake. Yeah. So if you see here, without outriggers, this building would have this much displacement corresponding to the height of the building. And if we put outrigger, the green thing is reducing your displacement at the top. Next, please. This is for a existing building, 68-story building. You see there are 2 outriggers locations, so you get a reduction in bending moment here and reduction in bending moment here. So, in the outrigger, there are two type of outrigger. One is the simple outrigger, that is direct outrigger, where the core is connected to the perimeter column through either the trussage or the wall, the RCC wall, which is a direct outrigger. And overturning moment is resisted, as I explained earlier. Sometimes we can't put direct connection from core to the perimeter column. In that cases, we entirely rely on the belt trussage encircling the perimeter columns. But the load transfer path is completely different here. So in this case, the load is transferred through your stiff floors. Whatever the belt trussage, you try to understand this, very, very important, how the belt truss works without outrigger, because the belt truss is built like it's a top chord is in the upper floor and bottom chord in the lower floor. And you know that in plane rigidity of the floor is there. So floor is a stiff, in plane it has more rigidity, infinite rigidity, because your depth of the building width will work as a depth. So what will happen, once the force will come on the core, can I go to the next slide? Yeah, this one. So once the wind force is coming to the core, so this force will come to the belt wall or belt truss, maybe truss also. So this belt wall will try to rotate in this direction, and then these columns will get a couple of force, compression and tension, which will just resist this overturning. So the core wall load has transferred to the floor, through floor to the top and bottom chord. So it is pushed in one is this direction, one in other direction, and then this belt wall is again trying to reduce the moment. Here there is no connection between core wall to the column directly. So this is called indirect outrigger. And this is the same way. You can see this is the floor, how the transfer of force is happening from floor diaphragm, from core, and this is how the transfer of force from floor diaphragm to column, and it is giving you the restoring moment through this compression and tension in the column. The same thing which direct outrigger was doing. This is just an example of truss. So if this is your core going up to the down, not shown here, up to the foundation. So this is the belt truss. So this will have a restoring moment here, but this restoring moment will also come to the flange truss, and then the flange truss, because it is not infinitely rigid, it is so there will be a shear lag, which is a very phenomena understood by in case of box girder, we are always have a shear lag, so we will not have the forces, and the corner column will have the more forces. and the inner column will have less forces. And the same thing will repeat if the wind is blowing for other direction, then this will become your web, and this will become your flange. Okay. So coming to the second part. So how to, go to the next slide. So where the outrigger has to be located. So location of outrigger at the building elevation at different heights, plan, number of outriggers, then outrigger truss depth, whether it should be 1 story, double story, belt truss to engage adjacent parameters, the structural material used for outrigger. So all this affect the performance of the outrigger system. Next please. So optimal location of outrigger will also depend on criteria what we are looking for. Outrigger is doing so many things. It can control overturning moment. It is also controlling top story drift, or it is controlling inter-story drift. So depending on what we are optimizing for, so the location of outrigger will depend. But in general, as a starting point, if we have to put only one outrigger, put it in the middle of the building. If there are two outriggers, locate one at the 1/3 height and second at 2/4 height, like that. And but you understand that whenever you are putting outriggers, that floor usability is reduced, because these outriggers are coming from floor level up to the top level, sometimes going to the 2 story. So that's why we cannot put it anywhere where the habitat floor is there, either office or residence edge. So generally we put it on mechanical floors, fire check floors, refuse floors, etc. So in practical, this location is quite dependent on your architectural drawings. So this is showing the optimal location of outrigger based on top deflection. So this is a theoretical study which shows that if it is located at 0.455 h, that is a half of the height, it will be efficient. Next. So just a 40-story model, 140-meter high building has been modeled. There is a core here, and outrigger is connecting this core to the perimeter columns. So this has been modeled, and then I am giving you the result of that model. Next. So here you see this is the graph without outrigger, and outrigger placed at different heights will give you these locations. And this is for single outrigger, this is for double outrigger, just to demonstrate how it reduces the overturning moment. So we have done with the theory part. So just I want to show you some outrigger systems which I have used on buildings or others have used in the building. So this is one of the building in a steel composite construction, steel concrete composite construction. This is a 240-meter tall building. Core size is 18 meter by 14 meter. So this is a quite slender core, almost 16.6 if you see the height. So core slenderness is high. This is a building here has RTC tower in Worli. So we have put 5 outriggers in this building, 2 at service floors and 3 outriggers at fire check floors. So this is the plan of the building. This plan also reduces at 102.5 meter, and then this is the plan of the building after 102.5 meter. Go next. So just I am showing you plan of fire check floor outrigger. So if you see here, this is the core of the building. These are the perimeter columns. These are the perimeter columns. So this is a outriggers which is connecting the core to the perimeter column. This perimeter column through this column. This is the perimeter column. Here we see the hybrid type of outrigger. This is a RC, and this is in truss. So this is a verandal truss, this is RC, again same. So sometimes it's not possible. It would have been ideal if we go in the straight line and my perimeter column would have been here. But sometimes it's not possible to do that. So we have to find a way to put the outrigger on a plan. This is a 3D view of the outrigger. You see these trusses. So here we have just removed the diagonals. We have not put the diagonals because somebody has to go and service these drenchers at the perimeter of the fire check floors. So how he will go if he will put all those 1 point trusses. And these are the, back please. These are the belt truss which is encircling the perimeter of the building. So belt truss is in a complete truss, not a verandal girder. Next. This is the photograph of the building during construction. This is the RCC core wall. These are your composite columns, and these are the outrigger trusses. Verandal girders omitted. Next, please. Again, a photograph, composite column, outrigger truss, and this you see the belt truss here. This is a 1 story deep. All the outriggers and belt trusses are 1 story deep. Next, please. And this is I am just giving you an example of 2 International Finance Center, IFC2 at Hong Kong. This is a 420 meter height building, 29 by 27 core. So 3 numbers of outrigger has been used. Back. 3 numbers of outrigger has been used in this building. If you see here, this is the core and these are the outriggers at a floor plan of outrigger. Next. So this is showing during construction the outrigger being constructed, embedded in the core steel, and this is the completed structure of outrigger and belt truss. Next. So somebody was asking about the connection. So connection of concrete to steel is very important, and generally this outrigger is connected to the column, and this connection has to be taken care of. This is a typical arrangement of a steel truss being connected to the concrete column or a steel column. Yes, just go ahead. Outrigger construction. Yes, go. So what are the problems we face with outriggers? We face reduced habitability of outrigger floors because it is obvious it is taking a lot of time. It's generally, if it's an RCC outrigger, it will be almost 1 meter of width and full height or double height or triple story high. So that's the one problem. Outrigger on plan, as I explained you, it's not possible to connect sometimes outrigger directly to the peripheral column because due to architectural considerations, the peripheral column may be at other location which the structural engineer would have desired. Okay, then connection is very complicated between RCC to RCC. If you are connecting an RCC outrigger to the RCC core, that connection is also very critical because you have to take care of all the forces being transferred adequately to the core. So your reinforcement should go there and it should distribute your forces inside the core deep. And steel to RCC connection is still more difficult. So you have to embed the steel plates inside. You have to, and there is a problem with the, because you can't, for a strain compatibility, you have to put the studs. So if you are making a steel connection to the core and there are studs projecting on both the sides, so thickness of the core sometimes has to be thickened on an outrigger floor. Maybe it's 450 at other floors, but you have to accommodate all the connections. You have to put 500 or 550 thickness. Impact on construction schedule is important because what happens generally, suppose we are going on a 7 days slab cycle with core preceding method, and the core is going up and the floor is coming and matching it afterwards for tall buildings, which is used everywhere in the world. So what happens once you come to the outrigger floor, your rhythm is gone. It sometimes outrigger floor will take 1 month to construct. So you have to take care of that, how to mitigate the construction schedule. There are many methods for that. I will explain in the next slide. So this is a very important aspect of outriggers. Any designer or whosoever is constructing the buildings with outriggers should understand. Then differential shortening of columns compared to core walls is quite important for in case of outrigger system. In general building you can just leave that, but in case of outrigger you can't leave that because it is going to have stresses in your outriggers due to differential shortening, which sometimes can be equal to the wind force generated by wind forces. So it has to be taken care during the design and understood by the construction team and the design team together. So I am just giving an example. Suppose there is a core wall and column, both is in reinforced concrete. So what will happen? Shortening in column will be more because core wall are heavy and core wall having more reinforcement, they are having more stiffness. So where the shortening will be more in column. So what will happen? The column will go down and outrigger, if it is connected with the outrigger at the column, so core wall will attract additional force due to this shortening and column will reduce in the column the force will reduce. So we have to take care of this additional force. It is coming to the core wall through the outrigger only. Okay, and this will happen in another way if core wall is in concrete and perimeter column is in steel. So what will happen? That core wall in concrete will have shortening over time due to creep and shrinkage, which will take more time. So what will happen? The core wall force, it should be other way around. Core wall force will decrease and column force will increase. It's just a typing mistake here. Next. So how to mitigate this problem of differential shortening? So there are many methods. Use of a special connection detail, control of construction sequence. Okay. No, this is working fine. No, this is okay. So use of a special connection detail, control of construction sequence, or use of virtual outrigger systems. So in many times what we do, that we just leave the connection of outrigger to the core, either to core wall or to the perimeter column during construction till the building is topped out, and we construct it afterwards, because if it is not connected to the column and to the core, then the shortening effect will not, loads will not come to the core. But there is a limitation. If you are making a 300 and 350 meter tall buildings, so it is not possible to the core alone to take all the lateral stability. In that case, during the construction period, once it goes up. So in such cases, mostly we have to connect at some time. We can defer it for some time, but after that we have to connect. A staged model is done, a staged model analysis is done with the floor construction sequence, and then after some time you have to connect the outrigger to the columns and to the core. So in such cases, even you have to take care of this differential shortening, even if it is connected after topping out. Suppose we are able to connect it after topping out, then also there will be differential shortening, because if it is RCC core, then your shrinkage and creep time dependent things will happen afterwards, after the completion of the building, topping out of the building, and it will have a differential shortening. Next please. So these additional forces cannot be eliminated but can be minimized. So there are some methods to it, like seam plate correction method in construction, wile jack outrigger joint system, cross connected jack system, by which we reduce it. So I will just explain to it. Go to the next slide. So suppose this is the column and somewhere here is the core, and this outrigger is connected to the column. So what will happen if you have not connected it to the column? So initially this gap and this gap, this gap to this gap, this gap to this gap is equal. If this column is shortening more than the core, then this gap will increase and this gap will decrease, as you see here in this next diagram. So this is a seam plates has been used to connect this outrigger to take it from here to here, so that this and this is already closing, the gap is closed, so outrigger is connected to the column. Here outrigger is not connected to the column because gap has increased. So we will take a seam plate, one seam plate from here, and we will put it here. So for doing this, of course, you need a jack. You have to constantly monitor it, and then you have to use a jack sometimes if it is locked with this seam plate to remove this. Next. Okay, so I will not explain this. This is another system where they use the vial, and then this vial flows through the orifice here. So once it is closed, gap is closing, it flows through the orifice. So what orifice will do? Because if shortening is happening, then this vial will flow through it slowly, but if at the same time how this vial flow from here to here, it is a pressure coming in, this will be V square, will be proportional to velocity square. So here this jack will be remain connected during the earthquake event or wind event, gust event, but it will not be, during the normal shortening effect, this vial will go and this will happen. So similar is the other systems. Go back. Go down. Yeah. So this is the actual outrigger jack connected here in one of the building from South Korea. I am giving you an example. Next. So I was just mitigating impact on construction schedule. So generally we use core has to go up. We use core preceding method for building. So core goes up and slabs come and meet the core afterwards. So if a core has to go up, and if you have made the outrigger, then how your system will move? Your climbing system will not move because their outriggers are obstruction here. So what we do, we make the core, this is called retro casting construction sequence in case of outrigger. So what we do, we suppose a core is 1000 mm, so only 300 mm in outrigger zone we reduce it, we put block out in your climbing system and we reduce it. So that way the whole thing will go up above the outrigger floor and my construction sequence will not be affected. Go back, go to the next slide. So now I am coming to the concept of dampers for tall building. Till time we were considering outriggers. So dampers are mechanical devices. How it is used? So wind behavior is very important. Understand that wind behavior is very important for buildings. So what happens if a building is standing like this? So once a wind gust come or seismic gust come, it will vibrate. And this is a natural intrinsic property of the structure. So once it is vibrating, if it is vibrating much more, then the person who is occupying the top floors, they will have a wind-induced oscillation. And they will feel that it's moving. So that has not to be there. So for that, if a strength criteria is already met by outriggers and still we are finding that it is going beyond that acceleration, then we put dampers, and dampers will reduce that oscillation. Okay, go to the next. So this is one of building constructed by me in Indiabulls Sky Tower. This is a 240 meter tall building. 200. So if you see, there is the peak acceleration at the top. It is generally measured in milli-g, 10 to the power minus 3 into acceleration due to gravity. And this is the this top acceleration, we generally take a 10 years return period of the wind. For a strength we take 50 years, but for services we take only 10 years. So if you see, if your peak acceleration is beyond 15, so it is not permitted. The top people will be feeling annoying for that. More than 15 mg. So there is a RWDI. RWDI is a wind tunnel study form. So they have given this criteria. Obviously for residential it is less because most of the time it will be occupied. For office it is slightly relaxed. So for residential it is 15. For office it is 20. So you have to do the peak acceleration in such a way. So here we have put one outrigger, RC outrigger, which is extending to a whole floor, and we have able to control this 10-year return period around 9 point something mg. Okay, next. So same thing can be achieved through dampers. So suppose due to even after one outrigger in that building, I am not able to reduce to below 15 because it's a residential building, then I could have opted for dampers. So dampers is basically either tuned mass damper or tuned liquid column dampers. So at the top of the floor, this mass is physically suspended from the top, and when wind is oscillating, then it will go in the other direction and it will try to bring the building back. Go back. Go next. So this is a very typical example you can find everywhere of the tuned mass damper. This is TAPI 101 in Taiwan, constructed building. So you see this tuned mass damper suspended from the top at the top floor here. So but the problem with this type of damper is it has a huge area occupied at the top floor, which the architects will not be happy. So now go to the next. So we are using viscous damper and viscoelastic dampers for the same. It takes very less space and it will fit in the less space. So how it will work? It will be connected to the two parts. One side is suppose outrigger, another side is column. So between outrigger and column, these dampers can be connected. Go to the next. So you see here, this is this is damped connection. These are the outrigger columns, this is the core, and these are the outrigger walls. So outrigger wall is not connected directly to the column, a damper has been put in between at different locations. Next. So this is a viscoelastic damper. So we are having different plates, higher strength plates, then bolts, and we are having a viscous layer in between these plates. So if we are having a 30 plus layer, we can have 30 plus layer of these VCDs, and this is a 3M viscous layer polymer. So what it will do, how it will reduce the damping, all of you know that this hysteresis loop area is more, the wind forces, gust forces coming will be absorbed by these dampers and it will not be transmitted to the building. So just nice. So this sorry, can you stop? Yeah. So this damper, if you see here, it has been put for a testing. So this was arranged with the CTBH Chicago conference. So in University of Toronto, this damping device was tested in front of us. So with 200 ton of wind load has been applied on this damper through these walls. So I am just showing this is the hysteresis loop generated during the testing, just to so any damper, if it is used in the building, it has to be tested. And other than that, one thing I would like to tell you, that these dampers generally they do not take for a strength, reduction in the strength, because these dampers are mechanical system, it can go heavy during the lifetime of the building, but it is not a rule that it should not be done. Sometimes it is done, like example is 115 North Waker Tower, Chicago, where TT is the Thornton Thomas TT is the designer. They have taken 25% of the damping thing into the strength of the building. And for that they have put alternative, if two dampers, one damper is required, they have put two dampers. So suppose one fails, the other will remain there. So with redundancy, you can use the speed. So I will show you this video is being tested. Just see that. Can you? The noise you are showing, the background is coming through this damper is going into the cyclic load of 200 ton.
So we can only show some portion here.
Okay. Next. How much time is? Oh, I am having few time. So lot of you are here from design fraternity. I am not that expert in design, but I have tried to put some basic things regarding what is the difference in outrigger design. So one thing is, outrigger system is comprising of core wall, outrigger wall or belt truss, and outrigger column. So this is an indeterminate structure, and hence interacts with core based on the relative stiffness of the three. Aspect ratio of core is important. Generally people see the aspect ratio of the building, but if you are putting the outriggers, you see the aspect ratio of the core. So if your aspect ratio is less than about 8, then perhaps outrigger will not be required. And if your aspect ratio from the core to the building height is more than 8, so generally it is beneficial to put outrigger systems. And if you have to control torsional forces, then of course you have to put belt truss. Next slide, please. So these are the basic assumptions to have the simplified model of this system. Perimeter column only transmit the axial force, core and perimeter columns are connected by outrigger, outrigger is rigidly attached to the core, so on. Next. This is very important. So have you seen this differential shortening is a very important aspect of design for outriggers. So there are self-straining loads, they are called self-straining loads, differential shortening, time dependent differential foundation settlement has to be checked. If foundation settlement is happening, then also it will have a force generated on the outrigger, effect of temperature. So all these straining forces, where it should be put, whether it should be put as a separate load combination, some designers put as a separate load combination, which is not correct. It should be taken to the similar to your lateral load resisting system. If you are taking into lateral load resisting system, what should be the load factor for this? So all this has to be taken care of during design. Diaphragm floor modeling is also very important in your model. So you cannot take it as a thin cell membrane, or you cannot take it as a rigid diaphragm. It will give you a erroneous result. So generally it is taken as a flexible, not flexible, it is taken as a semi-rigid diaphragm. Next. And this I want the students to understand, that generally it appears that you are putting a outrigger, very stiff outrigger at one floor. So how it is coming into the soft story concept and a strong column weak beam theory, which is a fundamental of your seismic load resisting system. So basically we should understand that soft story concept is not applicable for outrigger. Outrigger building has to be perceived as different typical floors having a particular level of stiffness, similar stiffness, and at the top you have a strengthened one floor. So perhaps a series of buildings, and it has shown that it gives you a very ductile behavior with outrigger, so it should not be a problem. Similarly, a strong column weak beam doesn't apply, because there is no question of plastic hinges coming in your columns, and similarly core to outrigger connection is also not plastic hinges is coming. So you should not have that fear in mind that this is not taking care of these concepts. Next. In fact, these are not applicable. There are some references, just you go through them. So these are the references from where I have taken some pictures, some other things. During my introduction, I just forgot about CTBUH, I forgot to mention that CTBUH gives a lot of publication, which is very important, not only covering a structural design. There are diverse subjects of construction, urban habitat, how that urban habitat has to be between two buildings, living spaces within the buildings, also for security of the building, sometimes for the wellness of the people there. So we have brought for this seminar, there are a lot of students. For this seminar we have brought about 20 books from CTBUH International. They have been put at the entrance of the building. Any of you who are interested can see the CTBUH publication there, just to browse through. And if any of you are interested, you can buy it from ctbuh.org. They are having the library there. So this will give you an idea. CTBUH is working on so many things. Thank you very much.
We may stay for questions. Some questions we may.
Yeah.
Yeah, we may take a few questions. Any questions?
How you find it very boring? My question.
Sir, how to minimize the creep in concrete? So, is there any ways and means to minimize the creep?
I think creep in concrete cannot be minimized because it is a time dependent effect. It will take care. Only you have to minimize is the effect of that. Like as I explained you, how can you mitigate the forces coming through the creep? So once you mitigate that, like a question, if suppose you have not engaged the outrigger, if it is a fairly not that tall building and it can withstand the core alone can withstand the load during construction. So in that case, you just not connect the outrigger to the columns, neither to the core, and even if the creep is there, it will take care of. For particular that period. But the creep occurring after the period cannot be eliminated through this system. So you have to take that into design. So if you are designing the outrigger, you have to take that straining load also into the design. So that way you cannot remove the creep loads, but yes, you can take care of the loads.
Maybe I can ask one question. So what is the typical philosophy used in this kind of outrigger based design system? Earthquake resistance. So generally for earthquake resistance, generally we rely on some kind of a hinge formation so that energy can be dissipated in form of inelastic behavior of the material. Here, since these are truss systems very stiff, we cannot expect them to yield.
Yes, yes.
Outrigger. So what is the philosophy, other than using some kind of an active dissipation system? What is the philosophy?
So one thing, if you see the typical arrangement of column to outrigger connection is not that rigid. So it is isolating. So something like base isolation, something like that. So there. And second very important aspect is when we are designing any tall building, at none of the time seismic forces are governing. Like even I saw this Seoul, South Korea Lotte Tower, which is a super tower, 600 meters. Wind forces is governing. For the South Korea, almost wind forces is to 1/3 of your seismic forces is 1/3 of your, and even if that building is analyzed with reference to Los Angeles earthquake, which is a very high region, then also it is not more than 2/3 of the wind. So that way generally our wind forces governs.
Thank you.
Sorry. Yes. To liquid mass dam, you can use the water tanks at the top as a liquid mass. But only problem is that water tank cannot be empty. So you don't understand that water tank can be used, because if that tank is empty, then it will not act as a tuned liquid mass damper.
So is there any difference between seismic dampers and this outrigger?
No, they are similar. Used in a different context.
So are they manufactured in India or outside?
No, this is not manufactured in India. Mostly it is, what I was showing you is manufactured in Canada, some is manufactured in US, so you can, Europe also, there are good manufacturers for dampers, because traditionally whosoever manufacturing dampers for seismic behavior is coming for the buildings also.
So what about high seismic regions in Chile and other things there, the seismic intensity is something around 8 magnitude, there also only seismic will govern the design?
There also the wind will govern the design if you go high. Because as you go high, your wind velocity also increases, and tall buildings are quite having a exposed area to the wind. So generally none of the tall buildings are governed by seismic.
Thank you, sir. Okay.
This, in terms of the
Yeah.
that has been proposed, soft story effect is not there, as what you are saying.
Yes.
But codal compliance is
No.
giving a reference of that.
No, codal compliance, because you have to use the code as per your concept. Because if this concept is not at all applicable, then
Tall building code, tall building code
16700 you mean to say.
refers to not allowing for any soft story effect into the building.
No, they are taking care of the all soft story effect, but that is not in reference to the outriggers. So if you are making an outrigger system tall buildings, so 167 they will become a code exceeding tall buildings. So code exceeding tall buildings has not to be 16700 has not to be followed, as per that. Only you have to go for a ERP, there is a peer reviewer is a must for if code exceeding buildings. More and more check and balances are there. But why I told it, because you have to keep in mind that a 500 meter building or 300 meter building cannot be designed exactly as per the code. You have to understand that this particular clause is not applicable. Not applicable. Even 16700 cannot be applied, because you see they tell that second do that. If the building cannot have a second mode of in torsion, second mode also should be in like either X or Y, then what you will do? You can't change the building. It is an intrinsic behavior. You can't change it. You can't do anything to do that. So we have to understand that code is, whatever code is telling has to be applied or not to apply.
India, which have been qualified by this, by the local government authorities, or probably for the high-rise buildings in Bombay and all.
Yeah, so your question is how it is done.
Yeah.
So when this 16700 code came, then we done a special seminar on tall buildings in Mumbai, and all of us were together. DMC, municipal corporation, that says that if you have code exceeding building, then you have to make a ERP system. So what they did, they have taken 5-10 consultants, 5-6 consultants, top consultants, and others as a ERP system. They have made it mandatory that once you are having a code exceeding building, then you have to go for peer review. For example, the Jai was presenting the building which is a 110-foot cantilever. So certainly it is a code exceeding building. And suppose you are making a 251 meter, the code is only covering 50 to 250 meter. So then it is also a code exceeding building. So there has to be a method how to deal with the code exceeding building. So that to HRC, high-rise committee sent, it will be revised by the designer and peer reviewer together, and then it will be passed by the BMC.
Thank you. We are slightly behind. Thank you, sir. Let's see.
To all. In fact, it's 1 o'clock now. Everybody is looking at the window outside here. That and myself, I'm a technical head for the customers. The Ultratech is from individual house to the multi-story structure we are involved. Just I'll give you, take you the journey of what we are and what we are providing services to you, and also there may be some doubts also that we can discuss in the lunch also. So see, everybody knows we are in minor in cement building products and ready mix. So cement, everybody knows actually, if you see the quantity and the quantity, but when cement journey, 1983 is a actually, when India won the World Cup, we started the first 1 million ton capacity. Thereafter, the cricket has not looked for a company. So these are the legacies and the 5 values we operate, which is I call as a Panchama, the values we operate very strictly and stringently, and the speed, which is the bottom actually. So what we tell is that we are not any customers, like for example a mason or a contractor, an individual house owner or engineer or any technocrats are there. Any missions, and the mission is to be the leader in building solution. That is the action mission, and these are the mission. So I will not take you, because this is not a product presentation, so I will not take you the very long way. So cement journey, if you see, Ultratech have been one of the largest companies, as I told you, excluding China, and we are pointing towards India's world's #1 also. Maybe in 2030 we are targeting that we will be the #1. So these are the statistics of what we operate, and we have almost 78,000 direct or indirect employees, where we cater to each and every talukas of India and other parts of country also. So right from cement, if you see, we have building products, which I'll take a little bit more of time of you to discuss with you, because which is one of the innovation we started in industry to have stakeholders. So these are the building products actually we have in a different segmented plasters and mortars also. We have changed the conventional method to the mechanized way. So that every site we cannot use this machinery. So what we have done, we have made a ready-made plaster in the bag of 40 or 20 kgs. A customer can come and easily apply. So that it will faster your rate of construction, faster your speed of construction, and also eliminate a lot of problems. Like if you see the shrinkage cracks, plastic cracks, or any problems related to the plastering, we can part to be treated by the customer or the owner itself, the apartment owner itself. So these can be at very easy at the customer base where he can get the kit and he can ask his applicator, everything can be done. So it's not in a segmental way, all product will come into this product. So apart from this RMC, if you know, we've been part of this journey for IIT Hyderabad also. We are one of the major part for RMC suppliers, and all these are this. And if you see, the important third part is that the first company to meet requirement of LEED and IPC certification, all the products which we supply. And also we have various solution for the urban road, especially in the white topping. We are pioneers, and we are one of the solution providers for the country itself that in the technology of white topping. So these are the new products we have started, especially the coastal areas is called Corro product, which enhances your the building life against the corrosion inhibition. So what I understand from the building last 25 years, that 60% of revenue flows for the repairs and rehabilitations. So that we can control through this better solution using this RMC of Ultratech. Now, Invernova Plus is a strong building green material where it is around 70 to 80% we use green cementitious materials in the concrete itself. So it's maybe termed as high volume fly ash also, but we use also other green building materials and recycled materials also we use for the RMC making, and we give the solution to this to the customers. Now third will be the decorative concrete, where it's called Ultra Facade. It is It's like another form of ultra high performance concrete, which concrete we manufacture concrete from M80 to M120 also. So all these been with a lean and standard structures we can manufacture. And the fourth will be duration is like a flooring solution in houses. Solution we have started like this, all these logos of the companies we associate and we try to give a product for a customer in a single stop solution as a in a form of shop. So any customer, or if you want to build a house in your home or village, you can go to that particular Ultratech building solution shop and you get all the products. Apart from Ultratech products, cement and everything, all these pioneers, what are the leading products we can get it in. So we are coming towards, stepping towards the customer's area, means to make his life journey a very simple way. So these are the services, and all these can be available, like solar services, rainwater harvesting, everything. So before I take the next slide, this is called Ultratech Birla Whites division, which is actually, if you see everybody, means all the major products, they will use this Birla White product. We have the normal white cement, we have putty also, and now recently we have started we make it comfortable for the workers to work comfortable life. So we have into the fragrance putty. So it comes in a different fragrance. So even while working also, the laborers will enjoy. Apart from the aesthetic part, so they will not feel uncomfortable. So this is one of the part we started. Then this is a primer coat also, which is a liquid primer we can use before the painting. Now, having said apart, so we started from cement, we started a little bit to RMC and white cement also. Now, one of the most important when we learn in Corona is that the connectivity. So many people were connected digitally, and the services have to be delivered because everything has stalled, but construction has not stopped actually. So many areas there was the road construction, many areas there was the rebase construction was, and cement was moving, and many areas we have to be in touch with the customers. So what we started an app called Ultratech UTech. It's a UTech app. You can also download. It comes in two segments actually, for the partners and the normal users. So if you are an engineer, you can download as a partner section. What will happen? It gives you a lot of recent trends what is going in the construction, right from the designing, right from the solution. Like for example, you want to give a solution to a customer, like you want a rainwater harvesting system. You don't know where to get, but if you go to this app, you can get the vendor from there. If you want to give pest control services to any customers, you can refer this one. So what happens is that the connectivity through app we are making, and for making this complete house, house means a dream house, all these services can be available through this one. So it's a physical and digital project we have involved right from this product. If everybody knows this building, I think everybody aware. The problem was in Corona where this solution was started when we have developed one new product called Sreoplast. Actually, during this construction, whatever before I started, I told that all the major products are involved. So we are involved with this Bangalore T2 terminal. Also, hotel comfortable riding facility was given through this tunnel. Fuel materials to manufacture. And these are initiatives, and we are 4-time water positive also. For whatever the manufacturing we are actually giving the back 4 times water to the environment. So all these are actually a snapshot. Since 5 to 10 minutes it was given, so I will not take you much time. And this is my last slide. Thank you so much. Any doubts, if you can visit into our website. We have a stall there. We have products also displayed. You can visit and get a lot of information. Thank you so much. Thanks a lot.
In a limited so now we will able to finish our lunch by hopefully say 2 to 10. Then all the delegates, including all the speakers and whoever is visiting from, we will see if we can arrange a quick lab visit. The lab is in the basement of the same building, so we can do that one. And in the evening, depending on your availability, if you stay back, then we can do a quick campus tour. So a couple of cars are available with us, and many of you are joining, probably have come in your own cars. So we can kind of go around and go to see some of the buildings in the campus. For the students, you are requested to come back at 2:30. We'll try to start exactly at 2:30. Morning we are late by 10 minutes. This time we will try to start because there are some people joining online also. So we don't want to make them wait, right? So please go for lunch and come back again on time. All right, thank you. And all the delegates and all the speakers, please stay back for lunch. We will join for lunch on the ground floor. Thank you. Mr. Gautam Basin is the regional director of Inhabit and is a building enclosure specialist, and he's going to today talk about the facade systems, right? So facade systems are very critical systems. Often structural engineers are not trained to worry about the facade systems. We are critical, especially in tall buildings. There are a lot of deformation requirements they have to satisfy. So you will hear more about them from Mr. Basin. Thank you.
Which one is?
Yeah, both of them you keep in pocket and this one you because one is for the online thing.
Done. That's right. How do I forward the slides? Can I use this? Right. I don't know. I spoke to someone that I've been very fortunate to get just the post-lunch session in the last 3 conferences I've spoken at. So it's going to be fun. Everybody's had a good lunch? Yes. Yeah, we'll try and stay awake for the next 35-40 minutes, so please bear with me. So we heard Jay, seller architect. We heard Mr. Kumar, seller engineer. I will try and balance between the art and science between the two, where it comes to curtain wall, which becomes the face of the building. But again, there's a lot of science, or what I call What we'll cover is this, the historical context, because it's important how curtain walls have evolved, and more so in the context of tall buildings and more so in the context of how CTBUH perceives tall buildings. Understanding of design and engineering parameters, which is the broad principles that I would expect structural engineers, I would expect architects to have at least basic understanding of, so you can ask the right question to your curtain wall specialist or to your facade consultant. Informed system selection, what system goes where, what is the right kind of system application for what kind of context, what kind of building. We look at installation and logistics as one of the key drivers. We look at cleaning and maintenance. Once you build it, how do you clean and maintain your facades? And then we look at some case studies. All case studies are widely different. Some case studies are of super tall, some are super short, but in every case there was a different question being asked, and obviously the approach of providing answer was quite different as well. Starting with the historical context, 200 years ago, 300 years ago, this is what glass application used to look like. I mean, you had glasses going in mosques, in churches, in form of stained glasses. We didn't have curtain walls, we didn't have windows, forget curtain walls. Then came the 1500s, where I think ordinary peasantry started to get more affluent, and then they wanted to introduce windows into their houses, into their homes or their mansions. But we didn't have float glass back then in the 1500s. So the only people you could go to for procuring glass are glass blowers in Belgium. They would take a big blob of glass, put it in a furnace, and then start spinning it till you get a circle or a disc of about 4 feet in diameter, and then you break it at this point. That was a float glass back in 1500s. And what you do is you cut small little pieces and then put them in a window. This was the premium glass. Closer to the punt or closer to the center was the poor man's glass, and this was called a bullseye window, because you suddenly start seeing these little punts in between. Optically not as clear, you can't see whether the sun is shining, but it would still allow light to come through. So again, this was the first step towards what we call as fenestration, what we call as facades. Then came Industrial Revolution, steel, steam engine, elevators. We basically took a massive leap within just about 100 years. In 1851, Crystal Pavilion was the showcase building where the entire industry came to flex their muscles. Included cast steel applications, but then the entire building had to be called Crystal Pavilion. So they devised a method to cast glass inside oak casks, and the biggest piece of glass you can cast without raising the temperatures uncomfortably high in the casting area and without the glass solidifying was used as a single module on the building, and the entire building was reverse engineered. So with that single module, how big a building can you build? And I mean, the poor building got gutted in fire and then it was reconstructed without the same glory anymore. So that was 1851, Crystal Pavilion. Comes 1952 and the glass industry's changed forever. That gentleman is Alistair Pilkington. We've heard the name Pilkington in the glass industry. He came up with a unique process. Instead of flattening it or putting molten glass between rollers, which had a lot of distortion issues, he took molten glass and rolled it over a molten tin bath, and that gave us float glass. Because tin's melting temperature is lower than molten glass, it would always stay in a molten condition, and because the glass sheet was floating over molten tin, it was called float glass. It is called the float process, it is called the annealing process, or it's also called Pilkington process in the honor of the man who came up with it. And from 1952 onwards, glass is being manufactured the exact same way. We haven't really changed much. Only thing we have done is added processes in that line, whether it's hard coats, whether it's tints added to the glass, or whether it's high performance coatings that go on glass, which then eventually becomes the product that we get at the end, which we then use on our buildings. Coming to tall buildings, while glass started to see this paradigm shift in its application on buildings, tall buildings themselves were taking their own leap or own path into the future. The building on the left is Home Insurance Building in Chicago. Chicago, as we know, where CTBH is headquartered, and Home Insurance was one building which wanted to really prove that you can build a tall building, which means all of the load would come through the skin on the outside, and there would be no windows, no shop fronts at the bottom, because again, the amount of openings you can have in load-bearing structure along the perimeter is very, very limited. And then again, there's only so high you can go with that. And then the walls become thick, which means the premium real estate, which is the top of the building and the ground floor, is the most compromised. So they came up with the frame structure. The architecture was still bonded to the time, so it had these sort of ornamentations, but this is what I would call a first curtain wall experiment. Around the same time, around 1926, we had Bauhaus. This is a design school in Germany that was more craft oriented, and they did this first experiment where they did a curtain wall with steel and glass, all sort of site assembled. What we used to do probably like 30-40 years ago, this is where it all started. Coming to tall buildings and coming to unitizing. Unitized curtain wall is, I think most people are familiar with the concept, where everything is modularized. This is where it all started. So between 1948 and 52, this is the United Nations headquarters in New York. And because it was a building built for the world by United Nations, there were, I think, about 17 architects around the world who were involved in planning that building. They wanted to really show what the future looks like. And they came up with so that was the design. Option 23B. So architects and designers who complain about like client bahut sare options mang raha hai, I think this is the number of options the architects ended up doing, and that's the consortium of architects that were involved in it. This is the building under construction, so you can see the concrete structure is going up. There is no scaffolds, no external access required for this, and the entire building is being built within 3 module panels which are hoisted and installed in place. So this was the first, arguably the first experiment in unitizing facades. And this is such a landmark movement that 3 of the panels, because in 2012, I think, they redid the facade of the building, and such a landmark movement this was that the 3 of the panels are actually kept in Museum of Modern Art in New York for you to go and see. And they've not been dressed up, they are as weathered as they need to be, just to see how a building performs over multiple years. First curtain wall to our shores. I think I was really young back then. This is Le Méridien in Delhi, and this building I think had a lot of weight put on in terms of approvals, because it's built in Lutyens, Delhi. As you can see, nothing is more than 4 floor tall, and this was allowed to go high. It was allowed to actually experiment architecturally, which is quite uncommon of that part of Delhi. So yeah, so from 1500s to where we had cathedrals with glass, now we're building cathedrals out of glass. I think we've come a long way, and the future is only looking more and more advanced as far as use of materials is concerned. So having looked at the history, or I would say very specific history in the context of curtain walls and high-rise, I'll go through a couple of parameters which I think are important for most engineers to know and have a basic understanding of. So you can ask the right questions, make informed choices without the presence of a facade expert in your life or around you. So that's, this is something we have on our wall where, everybody who starts looking at a design has to look at this as a sequence of importance. Obviously at the base of pyramid is the structure. If a facade can't stand on its own, it can't take the load, whether that's wind load or a barrier load or any kind of other loads, it's no good. It falls, it fails. Second is the environment. Facade is the only separation you have between what's outside and inside. So that's the skin that you have that keeps you comfortable against the adverse temperatures or adverse environment on the outside. Third is aesthetics. It's a face of the building. Building has to look good, it has to be maintained well, it has to age gracefully. And then last is cost. I wouldn't say last is cost, but cost is equally important. But all these 3 boxes need to be ticked with that priority. Unfortunately, what happens is this: you have cost goes first, we are given a budget, followed by I want this, I want this New York building in Hyderabad, followed by environmental, yeah, I want a LEED platinum or a LEED gold, and then structure dekh lena, you'll figure it out, I know. So, but yeah, I mean, you see the sheer importance of going from this to unfortunately what happens is this. Key design parameters, simple 10 points, structural integrity, like I said, it's an absolute non-negotiable. External loads, internal loads, any kind of structural movements within the structure itself. I think Mr. Kumar, I'll come to a couple of points where I'll link what he said with more clarity. Facade has to have allowance for movement. Now you saw how much a building moves. It literally is like a rhino, where when the rhino moves, you've seen the skin actually just skims over the surface, right? It has folds to accommodate, so that's equally important. So it's allowance for movement at number 2. Weather tightness, we need to keep air out selectively. On a good day, you should be able to open the windows, but the windows are shut. There should be no air exchange happening between inside and outside. But equally, we need to keep water out. We need to keep poor temperature, etc. Similarly, moisture and air infiltration control. How much of moisture? No moisture coming in. Selective or limited amount of air infiltration. Thermal insulation, very, very important at number 5. So you have sun radiating through the facade and heating the space on the inside, but just general ambient temperature on the outside should not come in. So the facade is your barrier from the outside to inside. Sound transmission, acoustically you need to insulate your building so you are actually comfortably either working in the office or trying to get a good sleep at home while you are next to the airport, next to a busy highway. So facade is the only barrier that's keeping the unwanted sounds, giving you some comfort conditions. Visual appearance, I don't need to say too much on that. It's important. It's the face of the building. Life safety, because it's the barrier on the edge. People falling over, not acceptable. Any kind of external impacts in form of threats. There could be bomb impacts. There could be cyclone-borne debris hitting your facade. So that's equally important. Lastly, cleaning and maintenance. Once you build it, you need to be able to maintain it. If there is parts that need to be replaced, there has to be adequate access provided for that. And then lastly, which I think is gaining more and more traction, and I'll take a couple of minutes to speak about it, which is sustainability and carbon. Going through the details of each of the parameters quickly. Structural integrity, one part is its own weight, it's self-weight. So again, it should be self-supporting between the supporting points, which could be 2 subsequent slabs. But at the same time, imposed loads on the main structure needs to be coordinated, need to be informed to the structural engineer that this is how much load I'm going to add to your building. Lateral load, I think, takes the cake in this case because self-weight is minimal. It's a lateral load that becomes important. So for that, you have wind or barrier load, barrier imposed load to the facade. So between 2 points, you have 2 elements that is spanning the gap. One is the frame, that is the structural component, and one is the infill, which could be in form of glass, it could be in form of some opaque material, some kind of cladding, etc. So frame size, it gets determined by it, infill thickness gets determined by it, and then finally loads imposed to the structure get determined by it. How much of load am I actually transferring onto the connection point here? That again needs to be coordinated with the structural engineer. With lateral load, there is 2 approaches. One is IS 875 part 3, which is the Indian code that talks about non-seismic loads, which includes wind load on structures, on the building skin. And then there's performative approach, where you literally put physical model into a computer, which could be a CFD study, or you can put it in a wind tunnel where wind is blown with transducers measuring how much pressure to expect on your building. With IS 875, or I think NBC 2016 also covers it in good detail, you have wind zones identified starting from 33 to about 55 meters per second, and based on the geometry of the building, where it sits, in what kind of context it sits, there are multiple multiplication factors that give you the wind load at typical zones as well as corner zones, and you can split them across the height of the building. That's with the codal approach. The other approach is where you model the immediate environment, where you have your building, which is this building in case, and then you have other buildings that actually change the dynamic behavior of wind quite differently, and it cannot be equated by a linear approach that code-based approach typically suggests. Now, here's the difference, right? So you have this building here, which is a code-based approach, and it's almost like a layered cake, where you can actually layer it further. Even by floor, you can change, and you can see the wind load increasing as it goes up. But interestingly, you see in the codal-based approach, you have the highest wind pressure sitting at about 1.75 kPa, but you don't see that 1.75 repeating anywhere in the performative-based approach. This is the wind tunnel-based approach, where it even tells you if there are hotspots in specific areas, in specific cases, which needs to be dealt differently. So I think the building can be more optimized. I think we were having a chat while walking back from seeing the labs that you can reduce crosswinds by a really big number, by a really big factor. I can't claim that you can save the amount of money you'll spend on your facade, but you'll have a more accurate representation of what your wind pressure is going to look like in the urban behavior. So three kind of parameters that we typically have for suggesting a wind tunnel test. One is if your building is in a very busy urban context, which is constantly evolving. There are new buildings coming up around your project all the time. You should get it done. In Mumbai specifically, anything more than 140 meters has been now mandated that you have to get a wind tunnel test done. The third one is if you have a very complex geometry where there are two towers or there's a flat tower with a big hole inside, then the wind behavior can be extremely dynamic. So again, in those cases, you should get a wind tunnel test done. And then if there is interest beyond that, that's always welcome. But I think this is the bare minimum that we normally suggest to clients in terms of testing requirements. Allowance for movements. Curtain wall is literally like a curtain. It's hung from top and it's released below. It's literally like our skin. If I fall unconscious, my skin is not going to keep me upright. It actually moves around, or it's just like your clothes. When you move around, the clothes move around as well. As you saw, the building sways in wind, which means one side there is the facade tends to get stretched a bit. The other side it tends to get compressed a bit. So imagine there is this curtain wall, which is essentially a curtain. This is where the curtain gets hung, and this is where it's released but interlocked with the panel below. So first is differential dead load. Buildings get occupied differently. One floor may get occupied now, the other floor may get occupied 6 months later. So there is more load here, which means this slab will deflect more than this slab. So that means at this point I will have to accommodate that deflection, which is again coordinated with the structural engineer. We get those values, we build those within the facade system and our specification. Live load, one office may be more crowded than the other. There may be some congregation spaces or a lecture hall like this where there's more load than standard transient spaces. So that needs to be accommodated there as well. Building settles, column shortening happens, concrete has creep happening in it, and that long-term settlement also needs to be accommodated within this one joint. So there is an equation which also includes cutting tolerances, fabrication tolerances, thermal expansion and contraction. So all those factors add up, and then that needs to be accommodated at this particular joint. Lastly, there's wind load. So when building stretches over to one direction, the curtain wall joints tend to open up. That's a value that's really important. And lastly, seismic. Seismic is a bit of a gray zone. There are some codes that allow glass to fail. There are some codes that don't allow glass to fail. Like Japanese codes do not allow glass to fail, so they have massive movements in their curtain wall joints, while in certain cases you have seismic activity exceeding a certain amount happening only once every 25, once every 50 years. So that's where you are allowed for glass to fail. But in my books, glass can't be allowed to fail because there are people inside. It's a big safety risk with the glass falling off the building. Water tightness is important, and in India typically what happens is that you're very trigger happy. You take a sealing gun, you seal everything, like ab pani andar nahi jayega. But I think the good principle of designing a facade is that you don't fight water, you design your system for water. So there is resistance built in multiple layers, and I'll come to that detail in a bit. So it has to be multi-chamber self-draining, and then it has to be self-cleaning. You don't have to have any ledges or any perfectly horizontal surfaces built. You need to have them in some kind of slope so the water is allowed to go out. You don't have any stagnation potential anywhere. Air tightness is important, not so much in residential application, but office application where your air conditioning loads are very well designed with certain amount of air exchange happening through your facade. But also natural ventilation is important in certain cases where you may want to open the window on a good day, where, I think Hyderabad sees more pleasant days in a month, in a year, in comparison to Mumbai, where we come from. So I think you should be able to take advantage of that and naturally ventilate your spaces. Thermal insulation, we live in tropics, so we get a lot of heat through the facade, and we are moving in the opposite direction where we are getting more and more glass on our buildings. We get heat into our buildings by two methods. One's conduction, which is through U value, and that can be catered to by using thermally insular materials, thicker insulation, double glazed units with an air gap, or perhaps something that's argon filled. And then second is radiation, where the sun literally shines through the facade into the interior space and raises the temperature, and that can be catered to by lowering the shading coefficient and perhaps then improving it further by providing external shading. Okay, some issue with the slide. Yeah, okay, so there's acoustic separation that gets added. So external sound, depending on the buildup of material and the resonance properties of each material, there will be a certain amount of sound transmitted through. So what are you designing for? What is your base case design? Are you next to a highway? Are you next to a train station? Are you next to an airport? What is the kind of sound levels you're dealing with? What is the kind of frequencies you're dealing with? That will determine the kind of system design that you will have. Visual appearance is important, and the top part is only purely limited to glass that I'm talking about. One is visible light transmission. We want glass, so we want light to come through as well. That's the entire spectrum of light in terms of wavelength. So you have 10 to the power of minus 14 all the way to 10 to the power of 4. That's being your wavelength, and somewhere between this, I think 380 to 780 nanometers is what is called visible useful light, which doesn't heat up your space, so it doesn't fall under ultraviolet or infrared or shortwave. And you can introduce coatings onto glass to be selective about only this part of light entering your space on the inside. So that again is an improvement in terms of performance. I can talk for 2 more days about materials that can go on facade, but this is what a typical palette looks like. Largely we sit in this region, this zone, which is metal in largely form of aluminium or aluminium composite, glasses, which is either single or double, or with frit or without frit. Materials that are gaining popularity, form of fiber cement, stone, terracotta, GRC, and porcelain in different forms and different thicknesses. Finally, life safety is important, edge barrier condition is important, so depending on what kind of space it is. If it's a public space, obviously there is chance that more people will congregate, more people will lean on the facade, so you need to design accordingly. And for residential or single family habitations or occupations, you can actually lower that load. NBC 2016 specifies that to a very, very good degree, very good level, for you to get an understanding of that. Fire and smoke compartmentation is important. We control our environment, but our neighbor may not be as responsible. There may be chances that a fire occurs here, and in case of a curtain wall, which is typically the system that we use for high-rise or maybe faster and safer construction, there has to be a fire separation here, which is rated so that the heat and the smoke doesn't bother you, or let's say in case of residential, let's say in case of hotels, even the adjacencies, or not just above or below, it's even to the sides. Lastly, you have blast and projectile resistance. Blast and ballistic is very limited application cases where there are sensitive buildings, which may be museums or government buildings or highly sensitive installations. There you need to do a blast impact assessment. How far and how much is the question to ask. How much of a blast impact load and how far away from the building, and then based on that, the idea is that the glass is allowed to fail, of course, in a blast, but the glass should really absorb the impact of the blast so that the person sitting on the inside is not impacted. And then lastly, projectile. So ballistic has the same thing. What gun, what bullet, and from how far. And then what is the failure criteria? If it actually goes through and hits the person, that's obviously failed, but it needs to reduce the velocity of the projectile to such an extent where it's not fatal anymore. There are government agencies which are run by the defense forces which do such kind of testing. Projectile impact, cyclone, etc. I think it's very uncommon in our part of the world. America, it's extremely common where you get these tree branches hitting the facade because they're part of a cyclone. And then lastly, cleaning and maintenance. I'll come to a simple diagram of understanding how to clean your buildings and what are the kind of systems available and what is the use case and limitations in each cases. So area allocation, where you have perimeter space in a building which everybody fights for in a normal building scenario, where you have MEP occupying that space, ownership wanting like a nice cafeteria, and then it's always a constant battle. And then second thing is system selection. One is height based, second is location and reach based, and third is what kind of system allows you to clean the building, how quick, and then if you have a certain cleaning cycle regime requirement, then how many such systems do you need to deploy on your building. So typically, if that's your building footprint, you're looking at a perimeter of 1.5 to 2.5 meters, depending on the kind of system you want to use. If you don't have the flexibility to use a terrace at all, then typically core is the best place to put a system where the loads are going directly through gravity onto the core. But that actually then has a requirement for an outreach which needs to reach all the way to the perimeter. But then in this case, the cleaning system is out of reach, as well as visually, because then you can utilize your terrace for whatever other purposes you may have. Typically up to 120 meters, you can use a self-climbing cradle which has the hoisting and winching mechanism built into the cradle itself, and that can be used with a davit or a monorail projecting through. Above 120 meters, you're looking at a crane-based BMU where the entire winching mechanism is actually sitting inside the machine on the terrace. Low-rise, and I've seen Burj Khalifa also being cleaned by men, window washers hanging down the building. So there is no real criteria for it, but we typically recommend it for low-rise because, with higher you go, the more wind can bother you, the less effective you are in terms of cleaning. But also a bigger challenge here is that you can clean the glass, but you can't have material replacement. Let's say if glass is broken, you still have to deploy some mechanical means to make a replacement. So that was the case where we had this sort of regular extrusions going up. You obviously have unique cases which then deploy very hybrid kind of approaches, where I think this is a building in New York where they have a hatch that opens up here, and then there's a long arm that drops the cradle, which moves all around the building. Shanghai Tower also has something very similar where you have a cradle that is articulating, so it actually folds inwards or goes back flat outwards to deal with these areas which are curving inwards, and similar systems used in buildings like this. I'll come to something that I think is gaining importance now. COP26, 2016, India committed that we're going to go carbon neutral by 2070. Our industry is going to be a big part of that change, and how do we drive that change? Currently, we are contributing to close to 40% of global carbon, whether that's in building construction while we build, which is embodied, or during operations of how much energy do we use to actually air condition our buildings and to run and maintain them. And that is compared to all the other industries, whether it's transportation, which is manufacturing, or the cars we drive, manufacturing, or perhaps agriculture and agro-based, which actually only contributes to about 9%, while we are an agrarian country. More than that, 33% of municipal waste comes from building scrap. We tend to renovate our apartments every 5, 7, 10 years, or less frequently or more frequently. Everything goes into a landfill. I saw a building built 20 years ago, and on the way to the airport I saw there were cranes demolishing it. It was a mall that was tried to revive, but then they could not revive it. Somebody paid money for it. Now they're going to demolish and build something new. All of that is going to go into a landfill. So I think sustainability in carbon has like 3 important aspects, and the reason why I'm stressing on it so much is that this is going to really impact the way we practice into the future. One is environment, second is energy, and then lastly, more importantly, is end of life. Do buildings have to go into a landfill? Can there be something that can be done? And I have a very beautiful case study around that of how could we address this end of life question. While we can be very responsible about green concrete and recycling and aluminium and recycling and all other materials, if we have to demolish it and throw it away, then there's limited use of actually being good on this side. So, three principles that come from consumer goods industry. One is design for environment, second is design for manufacture and assembly, and then last is design for disassembly. So you can actually take it apart responsibly rather than having to, use a jackhammer and then break down everything. With design for environment, there's multiple components. I think there's paucity of time, so I'll just focus on a few. Materials again have to be renewable, so that when they see their end of life, you can actually renew them back to its source. Production should require minimum components. Lesser the number of components, lesser chances of failure. Aesthetics should be driven by function and not just purely the beauty components. So I think the aesthetics should come from. I think if you guys want to take a picture of this, or large part of this is already available on the internet. Design for manufacture and assembly is about reducing parts. You're trying to make it easier for someone to understand and be able to put it together. It requires less level of skill. Design has to be modular, so it can be repeated more number of times, so you're more efficient in the speed in which you manufacture it. Standardizing components becomes important part of the modular design process. One part being used multiple times, which is multifunctional parts, and then parts for multi-use is equally important, so single component can be used in multiple applications. Lastly, design for disassembly is, I think phones are a great example. 10, 15 odd years ago, we had swollen battery issues. We throw a battery and pop a new one in, a phone would be as good as new. But now phones are literally like glued together. If the phone doesn't work, you toss it back into a drawer and stays there for next 10 years, and then you go and pick up a new one. One of the important things is you should be able to take it apart, and right to repair has become a norm now in the consumer goods industry. So to minimize chemical connections is the first thing, where you literally don't bond things together which are difficult to take apart. Everything has to be a mechanical connection as much as possible. Safe deconstruction, highly important. And then human scale components. So you don't require heavy machinery to take these things apart. You should be able to do it with 5, 10, 20 people, depending on the load of the component. Now, having spoken about carbon and environment, I have a case study which I'll lean to right close to the end of the presentation, depending on how we do on time. Coming quickly to systems, that's the domain of systems when it comes to facade. Facade could mean a window inside a wall, which is literally a punch window that goes into a wall. You could do a shop front or a window wall or a ribbon kind of facade, which actually still sits within the structural domain. Or you could do a curtain wall where the entire building is dressed from outside. You don't see anything. You don't see services, you don't see structure, all you see is facade from the outside. Typically in the domain of tall buildings, and typically the buildings that we see which are built tall, curtain wall is the weapon of choice. Within curtain walls, largely unitized curtain wall is what we use for doing glazed application, but other than that, there are applications where you build something as a stick system. I think I was observing the dining hall downstairs. That's largely a stick system where things are put together component by component. Great for a single 2-floor, 3-floor application, but anything taller than that, we would try and go modular, where everything comes together in components. Claddings are typically done as rain screens, and lobbies or fancy applications are typically done as structural glass, where you have glass with a single fin behind it in some form of patch that's holding the face glass. Anatomy of unitized curtain wall, extremely important, because this is very, very contextual to tall buildings, the way they are built. When I say unitized curtain wall, everything is coming in form of a module, everything is put together, which has all its function pre-built in. Only thing it's waiting for is two of those elements to come together and give you that structural, weather, acoustic, and the performances that we spoke about. So this is one half of the curtain wall. So you see there is a frame around here. You have the glass that is bonded to, it has an edge seal, it has multiple gaskets built within. The minute it comes together with the female component on the other side, it slides in, you have these seals that are formed, and that gives you one single frame which you typically see. So anytime you walk into a building and you see this little notch behind, that's an easy way to spot that it's a unitized facade. In terms of its performance, the way the chambers work, the way the weathering works, this line is the interior line on the interior. So this is where your interior gets separated. Unitized curtain walls are typically pressure equalized. That's the line of pressure equalization. So the yellow part is pressure equalized on the inside. So by changes in pressure, you don't wick in water or you accidentally invite water inside. And the line on the outside of this wavy line is the externally pressure equalized space, where you have these chambers that are designed to take water. So like I said, we don't fight water. We try and stop it here. If it doesn't stop here, it comes in. These are wet chambers designed to take water, and it goes down and it gets drained out. Now what happens, this is the plan detail. So this is the single frame assembly, as you can see in the plan. You go to a section that's designed to be a wet chamber. Additionally, that's also designed to be a wet chamber. So this allows water to come through, and there's a flipper gasket here. When there's ample water here, that allows that water to get drained out by its own hydrostatic pressure. And the way it comes together is this. So this is the dry chamber, internally pressure equalized. This is the wet chamber, externally pressure equalized, and that's the way the drainage works. So this basically allows pressure equalization, while all of the wet chambers are allowed to drain outwards. So you're not fighting water, you're smartly dealing with it, allowing enough chamber space on the inside to collect any water that comes in accidentally. Now we've seen systems, we've seen performance parameters, gone into a little bit of detail. I'll walk through some quick case studies, some tall, some short, but everything with a 5 minutes. Okay. Pertamina Energy Tower, I don't know how to classify this, super tall, mega tall, is like 523 meters in Indonesia. So the building is 523, the bottom 2/3 of the building is a straight extrusion, the top 1/3 is a curving extrusion that also leans back while it's reducing its flow plate size, so that actually gives a complexity in terms of double curvature on the surface here. With double curvature comes the challenge that you have to have flat panels. Now all the facade materials are manufactured flat, they are designed as sheets, as plates. If you have to do something a double curvature, imagine a big gym ball and you're trying to put playing cards or business cards on it, you'll always have this little gap that gets created. How do you fill that gap? You can triangulate the facade by having these kinks. You can bend it, which is the most preferred option. You can have it segmented in plan but stepped in section, and then lastly you can fish scale it, where you can actually bridge this gap in between. These are the comparisons when it comes to feasibility, cost, and aesthetics. The target was to actually make all of them green, so it should be feasible to do by local or regional contractors. It's also important that it looks good and it should fit within budget, otherwise everything else falls apart. We looked at a couple of project examples. This is IICC in New York, and this is Ocean Towers, one of our projects in Dubai, where a flat curtain wall panel, glass is also flexible, so is aluminium. It actually allows a little bit of movement within that. So we went back to the supply chain, where we designed this gap to be not more than 20 mm, going all the way back through subcontractors, to glass suppliers, to aluminum manufacturers, including butyl and silicon supplier, which actually hold the glass back. Will you allow us and warrant an application where you're pulling the curtain wall back and permanently straining it for its design life by 20 mm? And the answer was yes, and we could do cold bending, which was all done on site with flat panels without impacting the cost or aesthetics. Next challenge, this design joint was flaring outwards, which actually gave a lot of uniqueness to the facade. Number of unique panels were really high, and with facade modularity is extremely important. You need to actually increase the number of modules as much as possible. In this case, we had close to 1300 unique panels, which makes life difficult. If suddenly one panel breaks in between, your installation stops. You can't continue. With staggering the stack joint, with staggering the mullions a little bit, we could actually achieve panel groups. Number of panel typologies were reduced from 118 to 96. Repeated panels from 951 became more than double, and then unique panels became 164 from 1300. And those were largely limited to these areas, as well as these triangular panels that form the outer geometry. BMU, again for super tall, extremely challenging. This was the mechanical floor, as Mr. Kumar explained. This was also the outrigger floor. So we had to negotiate a small opening here where a BMU would pop out, and then it would run literally on rails on the outside of the building, and there were 3 such systems at multiple levels. For the top of the tower, again it's got this very unique form, so again we had to create like a shaft there where a BMU would literally rise up telescopically and then clean that part of the facade. I'll probably skip this one, given that we have a bit of a time constraint. This is an interesting case study. FWD tower run by an insurer, built by a Hong Kong-based client in Indonesia. Looks like a regular extruded building, but client's brief was very simple. They want to design it for the user from Indian, and they wanted as minimum number of mullions as possible. Typically a curtain wall, you're talking about a floor-to-floor height of anywhere between 4 to 4.2. Typical panel width can go anywhere from 1.2 to a maximum outer of 1.8 meters. That's what you can actually transport in a truck or even pick up with floor davits. So that 4.2 by 1.2 to 1.8 is this typical unitized module that you're looking at. The architects in this case were looking at mullion spacing of 3.6 meters. So every mullion will be 3.6 meters apart from each other. Makes it extremely challenging, and Indonesia is a market as rudimentary or as third world as we are. They have small trucks, they have limited, more manpower aligned than mechanical movement strategies. So what we ended up doing was to actually take 2 panels per floor. So instead of having a single stack joint, there were 2 stack joints. Panel number 1 would be installed from outside. Panel number 2 was placed on the inside, so you could literally lift it from within and then pop it back in, and then there is a restraint clip there. What you achieve, this was designed with Japanese seismic codes, 10.8 meter grid. If I do a 1.8 meter panel, which was the maximum feasible size of a panel, I get about 6 panels per grid. We could achieve this between a 10.8 meter grid. So very good clarity. Typically, and this had these big shades here because the building is also LEED platinum compliant, LEED US platinum compliant. You would end up putting all your desks against this transom here, which means what you're left with is this beautiful clear vision up there. And if you can see here, this is where the load carrying happens. This one is reduced more. So this is actually a 100 by 80 section. And this is unitized in a way where this is colored black, so it even has like less of a visual obstruction. I'll skip through this one again. Yeah, I think I'll probably skip. Yeah, this is important. I know you must have seen. I'm just skipping through tall buildings and coming to a little hut that we built in a campus. But this was an experiment I was involved in the last semester at CEPT University in Ahmedabad as a part of semester teaching at Faculty of Design. Why this building is important is because of all those factors that we spoke about. The building has to be low carbon. The building has to be designed for disassembly, and all those principles were the focus of making this building, and not to make it look good, not to use a specific material, not to any other factors. Of course, it has to be structurally robust. It has to have some kind of architectural symmetry, etc. It all started with the first principle that it's a habitation unit. You can habitate a space, calling it an office, calling it a home. So buildings have to be multi-use, buildings have to be flexible. If you stop using offices because of COVID, you should be able to convert them to a hospital tomorrow. The grids need to be flexible, the services need to be flexible, they need to be conceived in a way like that. So effectively, this was this long space. You could use it as a studio, you could use it as accommodation, overnight sleeping area, or a small office. Has a built-in toilet, fully serviced, a pantry and some storage. Again, this area is something that you can still modify to your needs, and has an outdoor deck. Couple of study models back in the early semester. Material of choice, again, structural material is the largest amount of carbon investment you make into a building, so that becomes the amount of carbon that you actually use for the rest of the life. You see concrete, structural steel, aluminium and double glazing all sitting in high 200s and thousands in kg CO2 per meter cube of the material of global warming potential, the GWP figure. But if you see wood or timber, it's in negative, because timber is essentially a carbon sink. While a tree is alive, it's actually absorbing carbon, so you can actually use that as a carbon offset. Again, building has to be designed for disassembly, so light wood frame or cross-laminated timber, which is glued connection, was never a choice. So we chose post and beam, but simple timber elements are coming together in a very simple structural principle. We use helical piles because when you dig the earth, you are literally infiltrating on what is an ecosystem habitat as well. And the principle here was you touch the earth as lightly as possible. Helical piles are just driven in place. If you want to move that building, you disassemble it, remove it like a screw, and the land that you actually took for occupying that building is left untouched. With structural principles, use available stock size as much as possible, so you're not wasting material. Wasting material not just from a cost standpoint, but also from an environmental standpoint. You're using stock sizes as much as possible. So a couple of structural grid options were explored, and this one turned out to be the most efficient. External panels, which became the wall, we needed to have the flexibility to actually remove one panel which may require replacement during this design life. So instead of doing a simple tongue and groove, we ended up doing a shiplap where you could actually remove one single panel and replace it during its design life. Framing materials we used for fenestration, wood, UPVC, steel, aluminium, all were choices. Given the amount of limited time, because this had to be built, conceived, designed and built within 4 months, we chose aluminium. Again, there's another experiment that's happening to replace all that building, the fenestrations, with a hybrid where the parts which are functional in the window are built in aluminium, but the structural component is built in timber. So for these reasons, tolerance, lightweight, yada yada, we ended up using aluminium. This was the site. Material coming in, a lot of these joinery is getting tested at 1:1. This is the workshop where there was no labors involved in this. 19 students built this whole thing. Yeah, just finishing. That's the finished product. Closing notes. I would like to leave this as a reading. Facade construction manual. That's the link. If you Google it, you'll be able to find it. This is a great reference point for anyone to understand more about the principles, get more detailed case studies, understanding of how facade functions. I know it sounds boring. National Building Code of 2016 is a great reference. It has evolved dramatically from the previous version, where they are talking about a lot of cross-disciplinary issues, where how the buildings actually come together and how buildings behave with multiple disciplines coming together. Two movie recommendations for the movie buffs here. How much does your building weigh, Mr. Foster? This was a question asked by R. Buckminster Fuller, the father of the geodesic dome, to Norman Foster. And then he went back saying, okay, your building is heavy. What does that really imply? Which means how light can your building be for the function it has? You don't really need to over-design things. And that has a carbon nuance to it. That has a carbon connection to it. And lastly, for the engineers in-house, there's a documentary called An Engineer Imagines. This is a documentary about Peter Rice, one of the engineers I look up to every time I want to seek inspiration in terms of how you can actually make engineering look beautiful. It doesn't have to be I-beams and channel sections being assembled together. There are good ways and good architecturally sensitive ways to do it. With that, I'll close my presentation.
Yeah, thank you for the very enticing presentation. I wanted to stop you a couple of times because you were kind of...
I understood.
But my turn also maybe the talk. Anyway, we move on now. We invite the next presentation, Mr. Babu. He's going to talk about challenges of building steel concrete composites from a developer's point of view, from structural engineering point of view. He may include some aspects of structural engineering. Mr. is the director of Phoenix Group. He takes care of growth and also the transition management. Phoenix is one of the largest and one of the first big groups which has utilized steel concrete composites in commercial space, and they are one of the biggest developers in Hyderabad. And we are lucky to have him here today. Mr. Babu is a graduate from Mumbai University, and he did a CA from Institute of Chartered Accountants. He also has an MBA degree from Institute of Management in Business.
Thank you.
afternoon, friends. I thank Council of Tall Buildings and Urban Habitat for giving the opportunity, and also IIT to host us and give us the opportunity to share our experience on steel building. So we started the day with architecture, then we went to structure, then we went to facade. So I will try to wrap up everything from the developer point of view, what it takes to deliver a building, a steel building. So I am the outlier here. All of you guys are from technical background. I am not. But I have been associated with this industry for quite some time. So I cannot call myself anywhere closer to E also of engineer. But I understand a little bit about what it takes to deliver a project. So I've been associated with Phoenix Group right since 2009 and intensely, very closely in the last about 6 or 7 years. I take care of the transition management and operations of the group. So what we are going to do is, I'll give you a little background about Phoenix, what it is, why it is. It's not about promoting the company in any way, but just to give the context of where we started and how we migrated to steel structure. So it's very important to understand the concept so that you'll be in a position to relate to one live example which we'll give in terms of one steel building, and we'll go a little more in detail to understand what it sort of took to deliver the building. And finally, we'll come to what are the positives and negatives of doing a steel building. We have to see both the sides. And if time permits, we'll go a little bit into the general challenges the industry is facing, but that's a bit like, subject to availability of time. And how we'll keep it is that the what part and why part I will cover. The how part, which is more technical, I have my colleague here, Kalyan. I will invite him at a later stage when you want to ask more questions, because during the lunch break also there are a lot of people who came and asked, we want to understand more about the connection details and how you put the insert plates and stuff like that. So I would rather leave to the engineers to answer all those questions. So I will cover the what part and why part, and how part we will leave it to the engineers. So we started in 2001, like any other real estate developer, based out of Hyderabad, predominantly, very limited operations outside Hyderabad. We had a little bit of operations in Chennai and some in Guntur. We were one of the pioneers in special economic zone. So predominantly at some point of time, most of the special economic zone were constructed by us. So we started in 2007. We developed and delivered around 17 million square foot till date, and 88% of them are IT office spaces. So we do very little residential, we do very little mixed use development. And we have 33 plus million square foot under development. About 50% of them are pretty much in the advanced stage of delivery, balance are in the planning and various other stages. So that's what we are as on date. So when we started obviously like any other developer, like RCC structure. So pretty much. Then in 2013, we have a very dynamic chairman managing director who always wanted to be little ahead in the so-called business or race, whatever you say. But he also is more like, aligned to sustainability. He is more aligned to, doing something different in the industry, better for the industry. So he started saying, no, I want to do steel structure buildings. And that time it was very limited, I would say, steel buildings in Hyderabad, or rather none I would say, or even whatever was there were very small structures. So we tried different types of steel structure with the different, we have done steel building with core wall in steel, we have done steel building core wall in RCC slip form, we have done steel building with encased columns, and we have done steel building with tubes filled with concrete. So you name it, we have a building to showcase to you, saying that even star columns encasing also we have done. So every possible type of steel building we tried during this period. So finally we narrowed down the most optimum level. See, one of the biggest challenge in the steel building is that the cost. It is certainly going to be costlier than your conventional RCC. And especially around 2020, 2021, the steel price went up as high as 1 lakh rupees per ton. And it was absolutely no way it was possible to sustain. So when the customer point of view, he is not going to give you an increased rent just because I am doing a steel building. He is still going to argue and negotiate with you that at the end of the day what I am taking from you is the space. So I'm going to pay you. Best of luck, you tried steel building, that only helps you. Though there is inherently many advantages of doing a steel building which helps the end user also, but they don't acknowledge when it comes to, this sort of rental negotiation and all. So we had to balance. And another unfortunate thing, this part of the world, is that the rentals that we get for a typical office building ranges between 60 rupees and 80 rupees, right? You compare this in Mumbai, it goes anyway up to 400 rupees, 350 to 400 rupees, maybe a very high end. Even you can standardize building, you can say about 200, 250. What it means? So when you convert this rental for a little bit, I'll move away from the engineering for a change. When you convert this rental, it translates into something called a sale value of the building. So when you take the sale value and reduce the cost, you arrive at the profit. So the lower the rental, your value of the building is much less. So if a 60 rupees rent, okay, what it translates to me, simple equation is somewhere around 7,000 rupees as a square foot per, if I have to sell the building after construction, it will fetch me 7,000. So 60 rupees rental translates into approximately 7,000 rupees as a sale value. I have to pay almost like 2,500 rupees, 3,000 rupees only for the land per square foot. All I'm talking about per square foot. On top of that, another 2,000, 2,500 minimum for construction. Then I have to pay for interest. There has to be something that has to be left for the developer. On top of that, if I have to do steel building, it takes a lot. And it literally pushes us in terms of margin and the profitability. But despite all these things, we wanted to do. So the only way we could do is to make sure that the steel building design are very efficient. So we had an internal target that we want to not to cross 6 kilo per square foot. That was our internal target. When we started at around almost like 9 kilos per square foot. Eventually, we reached 6 kilo, but it took, after meeting 30 different structural consultants, after doing almost like 5 to 6 buildings of different types, then we reached there. But still, if you ask me honestly, at the end of the day, when you calculate everything, direct, indirect, it lands somewhere around 6.3, 6.4. Why it is important? Every kilo adds to my cost. So I have to keep the cost down. Because on the other side, I cannot increase the revenue, because the user is going to pay a limited value only. So these are the challenges that we face. So since we started adopting the new structure, we have almost like completed 10 million square foot under the new structure. So I am going to show you a brief video about the group. It will not take more than 1.5 minutes or 2 minutes at best. So you'll get the idea. Okay, so the last of the project what you saw is the tallest of the building that we are constructing, which is almost like 225 meters, which is being tied in steel. And some of those wind analysis and other things what sir spoke about earlier, all these have been done here, carried out. So our development strategy depends upon safety, scalability. I will not dwell too much into all of this. Standardization, we pretty much believe in standardization. Most of our operations, processes, everything is largely dependent on standardization. We have a complete standardization process which we have internalized. We focus largely on sustainability. Most of the materials that we try to use are like environmentally friendly, and we do a lot of social related thing incorporated into this. And the most important thing is that our responsiveness has to be much better. So from when the client operation point of view or the market changes point of view. So all these are all incorporated into our development strategy as part of the thing. So this is something which you have, I think third time you are seeing in the fourth presentation. So 39% of the global energy, is related to carbon emissions coming from the buildings. So it is something very, it's an elephant in the room which you have to deal with, right? So why it is relevant here is that steel is not the solution, one of the solution to deal with this. So in the operation, during operation also it takes care of in terms of radiation, but also during the construction time also it takes care of being more sustainable. And more importantly, 98% of your steel can be sort of recycled after the building life is over, which is the biggest advantage. So more than steel as a solution, what we see is the steel as a value driver. Okay, how it can be a value driver? Speed of construction. Okay, so the next after this, what we are going to showcase a case study where you will see that how a conventional building, which otherwise would have taken 24 months, we got it completed in 10 months time, just because it is a steel structure, right? So that speed is very important, especially when you are in a ITES office building market, because many times client come and say that in this particular building it so happened that the client came and said that 11 months down the line we want the commercial operation to, or the fit out to kickstart. So will you be? Can you do that? In conventional RCC it would not have been possible. So the steel building was a solution, hence they came to us. So it also adds a lot of value in terms of who are all the people who can do the steel building. Then there are very limited choices in the market. So that way you are distinguishing yourself among the rest. Less duration, as I said, speed, higher productivity. Why higher productivity? Because conventional structures that you do, RCC structures, you will have to do in situ. Means you have to get the labor, you have to get the rebars, you have to get the concrete, everything you have to do. The productivity is a function of the people who are there at their delivering. Though the technologies have sort of improved tremendously, but still what happens, you fabricate most of the beams, columns and everything at factory. What you do is that bring those steel here and do the bolting or doing the welding part of it. That is the biggest advantage. It not only gives the productivity, higher productivity, because factory setup, factory environment, ecosystem is very different. Same you cannot expect to replicate in a construction site. It's a very big challenge. Less water consumption, of course, and lesser dead load weight against conventional structures. So those are some of the technicals which you guys, I'm sure, are aware about. What we want to do as a group is to move away to call as construction to assembly. That's a big, strategic mind shift, what you will call. Moment you make it assembly, what you do, most of the items you try to as much as procure which are pre-constructed outside, you bring it to the site, you do only assembly. So your dependency on labor comes down almost drastically 1:10 or 2:10. That is the level of difference that you'll have on the labor part of it. Stability wise, structural steel buildings are much better, which is one of the important thing for the client, because these are some of the boxes which they have to tick before they lease any space. As I said, recycling rate is 98%, which is a big advantage because many of those international companies look for buildings which are highly compliant to environment. So when I claim that, okay, my building, the recyclability is almost like 98%, I get an added advantage when it comes to when 4 buildings are compared. So I stand out saying that, okay, this guy is more sustainable, more environment friendly compared to all the others. So that gives a competitive edge or competitive advantage over other. So these are some of the basic features of steel building which helps to position us and use leverage in our business to make this whole proposition much better. But again, at the end of the day, is somebody going to pay me higher rent? No. By competition, will I be in the position to fight better? Yes, certainly yes. Will I be in the position to deliver the building faster? Yes, certainly yes. So those are all the intangible things which I have to drive. But certainly not, it's not going to add $1 to my pocket. So I'm going to, in the interest of time, I'm going to limit to only one case study, which is a building called Aquila Tower A. Okay, so it's about, in terms of built-up area, it's about 1.4 million square foot. 16 office floors, 7 stills, right? And another 3 basements. It's a typically most of our buildings you will see that grid, of 11 meters, and the typical floor to floor height is 4.05. That is our pretty much standardized thing, and most of the builders I think do the similar way. The 11-meter grid also helps in terms of parking and various other things. And this, the project was managed by Turner, and of course RSP was the consultant, and structural design was done by Stratcom. Leighton was the contractor, and we used slip form to do the core. Not many are aware that slip forms are typically used in your silos and various other larger structures. Here we try to use slip form to get the core. The advantage in slip form is that you do every 300 mm you keep slipping. And in a week, you can almost get 10 to 12 meters of core wall in the coming up. That's the biggest advantage. There are some disadvantages. You have to be very, very cautious about the quality, and you have to be very, very make sure that your concrete design mix is properly done. Otherwise, you'll end up having a lot of issues. And structural steel erection was done by JSW Summerfield, which is JSSL. Okay. Now, height of the building was 106 meters. It's a pretty standard buildings in those areas. Total, as I said, above podium 24 floors, including parking floors. The duration from start, so okay, I still remember it was 1st of January 2021. COVID at its peak. We were just above the basement. Basement was almost done. From there we started. The Bhumi Puja was done on 1st of January 2021. End of 10.8 months, the building was complete. All the facilities were put inside, and we got the fire approval from the department, and the client was handed over to start the fit out. I would say that the quickest possible building that I have seen in our history of Phoenix. I am not going to compare with others. So what it takes, 6,800 tons of steel to be fabricated and delivered in a span of 5 months. You know the biggest challenge that was we ever faced? For steel fabrication, you need oxygen, right? And the maximum steel was fabricated in the month of May, June, July. If you all recollect, that was a peak of the COVID second wave. Government gave an order that all the industrial oxygen has to be diverted to hospital. Nobody can use, oxygen for anything other than life support thing. And that is the time our structural steel erection was going on. There was a delay of almost like 21 days. No steel coming to the site. Despite all the odds, we somehow managed. There was some stock available there, and we could pull it off. There are a few other challenges. Labor was not available. Labor, there are a lot of COVID restrictions. How many people can be there in one confined place? So, despite all this, we could manage to pull it off. Thanks to all our partners. Approximately 30,000 cubic meter of concrete, and the facade 3,500 panels, and maximum at some point in time 1,100 workers, because we had to double it up. Normally we would not expect a steel building have 1,100 peak manpower, because the whole schedule was crunched, and because of COVID, in between there are lockdowns. We were not permitted to work. More than 100 workers were not allowed in the site. So with all these restrictions, some point of time for finishing work we had to augment people, so that went up to 1,100. Otherwise, a typical steel building you won't cross 500, 600 at best. Especially after structure completion, maybe it will come down. Structural completion also only for RCC structure. If there is a core is RCC, you might need additional labor to tie the rebar and other things. Otherwise, you won't need so much of. You won't believe this whole building would have been constructed. The structural steel erection would have been done by only 30 people. If imagine if I had to do that whole of that building with RCC, This 1,000 would have been there for next another, 10 months or 12 months. Not that I'm disregarding the RCC in any way, I'm only giving the comparative statistics. So just to give a contextual reference, so I've just compared 5 different structures so that you understand in the context of steel what it takes. So Empire State Building, 380 meters, 66,000 tons of steel was consumed. This, of course, almost nearly closer to 1890 years back. Burj Khalifa is not a steel structure, it's pretty much RCC structure. Largely 39,000 tons of rebar was consumed to develop the structure. So that is not a comparable point for a moment. Eiffel Tower is only framed structure, right? 330 meters, but look at the tonnage of steel, only 7,300 because it's only a frame structure, right? The loads are not much except the people movement and stuff. The Shanning Square, which is in Shenzhen, China, is 384 meters, 24,500. So what you are seeing is that almost for every 100 meters of building height, your steel consumption world across is about 6,000 to 7,000 metric ton. So same, and our building is 6,800, 107. Here I think we got the coefficient of somewhere around 6.36 or something, if I remember correctly. So it's a non-tower area, the podium and below is RCC with PT slabs, and the tower area, main tower area was composite steel structure, and what we could achieve was 6 days per floor, and including all the delays and everything. The columns are in CFT with infill concrete, no rebar inside, but there are studs to to give the strength. I think our technical people will be in a position to explain much better. Beams are built up sections and combination of plates of 350 and 450. So predominantly we use 450, we don't use 350. In this project we used some amount of 350 in certain locations. And the core walls, slip form, as I said, 12 meter per week is what you can achieve. And we used concrete boom placer tower cranes. Another important point, somewhere there was a reference with respect to mechanization of operations, how advanced we are. You won't believe, we couldn't get a luffing crane in India to erect steel. Why luffing crane, you might ask? Because this structure, on one side we have a hospital already in operation, on the another side we have our own existing building, back side we have a residential building, front side is a road. If I have to put a conventional, normal crane, hammerhead crane, I would have had issues of operations. At best in that location I would have been able to put 2 cranes, and both the crane would be required for my slip form. Now I have to erect the structure also, and I need another 3 more cranes. So if 5 cranes have to operate in that location, the only way I can do is to have the luffing crane, so that you can still have a little bit of flexibility in terms of which crane is operated when and everything. So the clashing won't happen. We had to import these cranes, and because it was not readily available here. Most of our partitions wall are Aquatech panels, which is manufactured by a company called Robomatic. Most of our walls, we use very less brick walls. So 1st of January, as I said, 2021, we started the project, and rooftop structural steel 22nd September, and concrete 29th September, facade completion 7th of November. So while the construction was going on, parallelly we were doing the glass curtain wall also was going up in parallel. And because we had the basements ready, so we could push all the MVP and services and everything quickly into that. And the fire inspection was conducted on 19th of November, 10.8 months. If we had to do this in a conventional, probably it would have taken about 24 months, is based on our experience. So, as I said, the challenges: oxygen, fabrication delay due to non-availability of workers at the factory. Factory was shut in between, and BTS requirement as per inducer. So this facility is used by a client called Micron. You know Micron, right? So, and they are having a lab here. So some point of time they came back and said, we want to increase the load of the structure. Means load of the structure means we want to put additional load on the structure. So you have to do the retrofit. So we had to go and do a little bit of a retrofit to allow them to put the servers and various other things. So those other things are possible in a steel structure. But it's not that it can't be done in RCC, but the method of retrofit will be very different. I will skip this. Okay, a quick 1-minute video of construction time lapse. You will see how this whole building has come up. Moving. It will not take more than 3-4 minutes max. So what are the benefits of doing composite steel structure? One is the speed of execution, which you have seen in the live example. Offsite production, which is very important. When the biggest advantage of offsite production is that dependence in the labor is much less, and another big advantage is the quality. When the beams are fabricated in the factory, when it comes here, what we have to do is only do the bolting part of it. So the final finish that comes out is very good. But if it has to be in situ, then you have to make sure that shuttering is properly done, the concrete is properly poured, then curing is properly done. When you pull out that shuttering, you have to make sure that the formation levels are perfectly okay. There are no undulations, and there are many things that goes behind to achieve the quality that we desire. And the increase in usable space, which has been touched by, I think Jay touched it in the morning. So you require a reduced column size, so that it gives the opportunity for the client to use in terms of more space. Quality we touched upon. Modification to suit customer requirement. If I have to do a RCC structure, and if the client says, okay, I am taking 2 floors or 3 floors, can you give me a staircase internally? It's not possible. Maybe it might require a complete, reconfiguration of the building and stuff like that. In steel buildings, it's pretty easy, right? I have to just strengthen some of those beams on the in and around that opening, and I can just unbolt it, remove that particular portion, and create a staircase. And this we have done, I think 2 or 3 instances in the past. Of course, it requires municipal approval, but the whole thing can be done in 2.5 months without much of additional cost. So there is one client in one of our building where he has taken 3 floors, and within the 3 floors he has put a staircase of his own, so the employees can move up and down easily. Those sort of options are available in the steel structure. Recyclability, even that another thing is that build to suit is that if the customer wants some certain specific area, they want it to be additionally put additional load, and that is possible by introducing additional beams underneath, and giving that, or you can even strengthen the column by doing some amount of retrofit. Material is recyclable, so that gives an added advantage. Flexibility in design. Environmental sustainability, we have spoken about it, and the seismic performance is much better in steel structure compared to your conventional RCC. So these are some of the benefits. Yes, there are challenges too. Higher cost per square foot. On an average, if my conventional RCC structure is costing me 1,400, 1,500 rupees per square foot, this would cost me additional 300 rupees per square foot, right? So this is our 300 to 350 is the cost additionally that we are incurring in steel structure. And there are very, very limited vendors available in the market to do steel fabrication. In morning I was speaking to sir, so basically there are 2 types of vendors. One who does a lot of complicated structures, like airports and everything, but they don't go by mass volume, they go by the complicated structure design, heavyweight, each of the span would be maybe like 50 meters, 60 meters, those sort of structures they will do. And there are people in the market who do large volume of repeated elements. In our type of buildings, we need contractors who do a lot of repeat elements, so there are very limited vendors available in the market. Fireproofing is the additional activity that you have to do in a steel structure, but throughput cost, whatever increase 300, 350, I am saying including the fireproofing cost. There is a huge burden on site logistics. In a conventional RCC structure, you can just bring the concrete as and when you want to pour. Only material that you store at site is rebar at best and shuttering materials. But in steel structure, you have to always have 20 days, 25 days stock available, and these are all heavy beams, odd size columns, and they need to be lifted and put into the building. Suppose if you are doing a building where all the 4 sides are already existing structure, doing a steel structure with all these materials coming into the site is going to be a little challenging. But it's not impossible, but the logistics is going to drive the schedule at some point of time. If it is a little away from the city, there is no problem. But if it is in the city, then you will have a challenge when it comes to steel structure. Other than the RCC structure, you can just bring those trucks and you keep pouring concrete as much as you want. So it won't be much of a problem. Then additional coordination between civil and steel vendor. The steel vendor who does the steel assembly doesn't do the civil work. The guy who does the civil work doesn't do the steel work. So you are introducing one more contractor, critical contractor, and coordination between them is going to be a bit of a challenge. And finishing, if you are having a steel core and if you have to do a brick wall and both have to be joined together, you will always have a challenge of how do you do that, because both behave very differently. Right? So there are solutions available, but it all depends on what type of material that you are using for your partition wall and for the core. There is a little bit of increased vibration which is acceptable. It's not that it's not acceptable range, but people who are used to a conventional RCC structure will find that steel structure, they feel that something is shaking and stuff like that. But you go to any US, in any of those developed countries in steel buildings, you feel the vibration. You go to, forget about all this thing, you go to any bridges, which is rivers, bridges crossing the river or elevated highways and stuff like that. You go in the middle of the thing, you will find that some vibration. In the car you may not probably perceive that, but the structures do have vibration. But in steel structure you feel it because you are sitting in the office all the time. Relatively high risk operation because each of the element that say the maximum size weight in terms is about 6 tons or 6.5 tons in terms of column, 2 tier columns, that is 8.2 meters column, 2 floors together. And the smallest of the element is about 400 kilos, the beams, secondary beams. So all these need to be lifted and placed. So in terms of operation, in the concrete what happens, you just connect it to a pump and will keep pumping the concrete. Only thing you probably lift and put it is either shuttering material or probably rebar, and that also doesn't happen quite frequently. Here, if I have 4 cranes on 4 sides keep sort of assembling material, each of the crane normally does about 25 lifts each day. So that means you are talking about 100 lifts of 400 kilos to 4 to 5 tons being lifted at different point of time in the day and being placed. So the level of the safety management at the site has to be at the highest level. That's why I'm saying this is relatively high risk operation. It's not that it's impossible to manage, but it requires a little bit of a larger team to manage the whole thing, like signal man, flag man, and this type of the various type of people who operate all this. So last slide. The rest of the thing I'll skip in the interest of time. So if I have to say the biggest strength for doing the steel building is that the load bearing capacity and strength, which helps as a developer to use it as a marketing tool. If you ask me what is the biggest weakness, initial higher material cost and construction cost, it is always going to dampen the spirit of the developer because especially in a lease rent sensitive market like Hyderabad, it matters a lot in terms of you can't always revenue increase, you have to always focus on the cost reduction also. Opportunity, sustainable development, environmental conservation, in addition to that, marketability of the steel building is much better. Especially if US based company has to, if there are 4 competitors, if I am standing, they would prefer the steel building unless my location is too far off from other 3. Finally, challenges, there is going to be resistance because there are not going to be a lot of vendors, sub-vendors available. Another thing is that in steel, like in the beam and column, you cannot go and puncture anything. There are regular openings which are made available. In a conventional RCC, you might go and put some few nails and make some few brackets and other things done. But in steel structure, it's not possible. So there are going to be a lot of resistance we feel, and there are lot of trade experts available in the market. Even fireproof painting also, Sir knows, like, there are not many companies who are available. There are only those 3 or 4 players within whom we have to somehow manage. Recently, one of the project, the material was supposed to be coming from England and London, and because of the Houthis attack in Red Sea, the whole project got delayed by a month. So these are the elements, sometimes it comes as a surprise on face of us. So very difficult for us to handle. So with this, I will conclude. This is the last thing which you have to remember. There is a long way to go. Generally, it is perceived that, there is a lot of efficiency that we have to bring in the office buildings. I'll skip all this. Thank you.
Thank you, Mr. Babu. Actually, we are behind schedule, so I will skip the session. Anyway, we have an informal session for discussion in 15 minutes. At that time, you can ask technical, non-technical, whatever questions you want. So let us move to the final presentation of today. This one is a sponsored presentation by Mr. Rajiv Wist. He is the head of technical marketing from CTMT.
In my pocket.
It hasn't come on the display.
Put it there.
Sir, one second, sir.
Stop.
PPT.
It's not easy. Yeah. We can have it full screen. Namaskar and good evening. I'll not go through PPT and all. I think you all have been going through it. It has been a thorough learning session for you. To begin with, I am privileged and I am thankful to Dr. Surya and Engineer Yasin for giving me an opportunity to be here in front of you, addressing you all. My name is Rajiv. Fortunately, I am an IIT Delhi alumni, but from the Department of Management Science. There is a small section in IIT Delhi Department of Management. Right. Now, I will not talk much about steel. Dr. Jagdish has already emphasized a lot on steel and the importance of the steel on the structure. I have scribbled little few things which I would just be telling you. It is expected that by 2030, Indian urban population in major cities would cross 600 million plus. That means, within the city we'll have to find the growth opportunities. To put it simply, we have left no other option but to go vertically. We need to have skyscrapers. And while we are talking of skyscrapers, let me quote one thing. Sky is not the limit. It is just one thing which is outside my window. And believe me you, that day is not very far, and we would have actually seen it and experienced it in many of the urban cities of India as well. As per ANROC, a research group, it states that the central and the state government are keenly watching, integrating and approving construction of buildings which are 40 to 70 floors. Now that speaks volume when we are talking about tall structures and buildings. Needless to mention, the high strength and high performance concrete and steel are the most important technological advancement which has brought a remarkable change in the high-rise tall building construction. I remember Mr. Gautam Hasim stating, thank you for your attention, Mr. Gautam Hasim stating that from 1851, happened when the steel structure was included in the construction. And that change was for good. Aptly emphasized by Mr. Jagdish that the challenges while constructing tall buildings and how special emphasis has been laid on steel. I remember Mr. Jagdish stating steel as a value driver, if I am not wrong. Now that steel, talking about steel and steel, reminds me of my band, Sri Extra TMT, and that is what I am here for. Right? Besides meeting those chemical and physical parameters, which we all have to, the extra rib patterns, if you see in our steel, there is 3 extra rib patterns, which gives extra bonding with the concrete. And this actually enhances the stability of the building. And we have been talking about that. And before I say thank you and goodbye to you, let me also, and before I conclude my request to you, there were many challenges which Mr. Jagdish emphasized. And I have selected few. The selecting material, there are huge burdens and challenges, selecting material, vendor, their work scope, logistic, commercial aspect, high risk operations, fabrication, isn't it? So many challenges. But my humble request to all the budding engineers, you there, don't let the tall building, skyscrapers, and the dreams in your heart crumble. Thank you so much. And I'll request you to play the video. Yeah, I'll put it in. मैं वो आता हूँ।
thanks and gratitude to Agrawal sir for conducting this wonderful. Thank you.
All right, so now with this presentation, we come to the end of the formal way of seminar. Now we have especially earmarked approximately 45 minutes for an informal interaction, because wherever it becomes critical that our students at the time and questions they want to ask, get their opinion on that. So I would request students to take initiative for this session. But I would say that all the speakers and all the other
engineering group at IIT Hyderabad and very active computational research. Professor Rajagopal heads the computational structural mechanics lab in the Department of Civil Engineering. His research work focuses on multi-scale approach to modeling damage, track initiation and propagation in different materials under quasi-static and dynamic loads, and modeling dynamic fracture using novel non-local phase field method. His research group also works on development of the pressure and strain rate elasticity-based damage model for concrete. The model can predict dynamic mechanics like crack propagation and damage behavior of the material. He has made substantial contributions in the area of modeling of interface elements and masonry structures. His research also focuses on developing novel computational methods like n-sided polygonal finite elements, mesh refinement techniques, and Simpson interpolation. Professor Surendra Somala specializes in the fields of structural dynamics, engineering seismology, and structural health monitoring. Vibration of typical structural systems were traditionally reduced using isolators like elastomeric bearings or friction pendulums. But for the path-breaking science, equipment like laser interferometric gravitational detectors would benefit from metamaterials concepts which would render them invisible to even ambient vibration. Vibrational modes of structural systems like bridges, offshore wind turbines are used to help in health assessment and damage detection. However, advances in artificial intelligence has led to rapid localization in real time through automated surveillance. Vibration monitoring of Earth can help in early warning secondary and tertiary waves of pandemics like COVID. Days like Janata curfew were prominent in higher frequencies. Vibrational characteristics of asteroid impacts on heavenly bodies, like Moon, help in zeroing out on the basis for the placement of advanced science equipment. Professor Vishnu Bhattacharya heads the Stochastic Computational Modeling Lab at IIT Hyderabad. His research group performs cutting-edge research on developing efficient models for uncertainty quantification of stochastic problems. The group develops meta-models for stochastic dynamics and impact dynamics problems with the help of advanced data-driven and physics-informed machine learning technologies. The research group also develops efficient artificial intelligence-based models for computational mechanics problems such as fractures in different materials. At the same time, it performs reliability analysis of different civil engineering structures under different environmental conditions such as windstorms, earthquakes, and fire. The Structural Engineering Division has a very vibrant group conducting research on construction materials. The research group headed by Professor K.B.N. Subramanian focuses primarily on material characterization, concrete performance improvement, and alternate binders and geopolymers. The group is actively engaged in the processing and rheology control of concrete for different applications, such as 3D concrete printing, self-compacting concrete, and cellular concrete. The research group is working on the development of the 3D concrete printing technique for use in structural applications. is the research group focusing on the development of low-carbon concrete through the use of industrial byproducts and construction and demolition waste to produce sustainable building materials. The group also focuses on using partially treated wastewater as a substitute for potable water to produce concrete. The group is working on solutions to use and store carbon dioxide and cementitious materials to contribute to net zero emission targets. The condition assessment and strengthening of concrete structures, that is, Gastcom lab is led by Professor S. Surya Prakash. The Gastcom group primarily focuses on condition assessment and strengthening of concrete structures. Notable achievements are high performance concrete using locally available materials. The creation of the split Hawkins pressure mark for obtaining dynamic properties of concrete, the design of a customized road for split, establishment of a great center for testing GFRPB marks, a rarity in India. Drawing inspiration from the government of India's efforts towards sustainability and affordable housing, this group has been dedicated to developing lightweight and foam concrete for structural applications. The Structural Steel Research Group is headed by Professor Mahendra Kumar Madhavan. His research is primarily focused on arriving at unique and innovative solutions for the need-of-the-hour problems such as housing shortage and sustainable future. His group has made major contributions in the fields of both formed steel members and connections, steel concrete composite construction, structural steel strengthening using advanced composites, and full-scale testing to simulate extreme events such as cyclones and impact of debris during a cyclone. Professor Structural and Fire Engineering Research Lab at the Department of Civil Engineering. His research group focuses primarily on structural safety in extreme events such as fire, earthquake, and impact loading conditions. The group employs large-scale testing at elevated temperatures representing fire conditions, under cyclic loading representing earthquake conditions, and high-strain rate testing representing impact conditions. The group has also made contributions in the area of vision-based techniques to evaluate structural damage in steel members. His group is also actively engaged in developing lightweight, high-performance structural systems for infrastructure applications using FRP composites. Such systems can be very effective in providing faster connectivity to remote and inaccessible areas.
Thank you. All right, so maybe I can, it will be difficult to connect to the mic because speakers are all different. So, audio, are you able to capture the audio from the ambience? Can you switch to ambience and then you can just use that one? So,
adopted in your projects, and were the clients how? So now, how the regulations have been have been done for those kind of design considerations?
Which talking about the CFT columns also part of the codal compliance. While that is there are other codes which are Euro codes and American codes which are available. So wherever the high-rise structures are designed, typically to the extent even the code says as part of the understanding, largely two perspectives, one being the prescriptive approach and the other one is a performance approach. So until the area where it is prescriptive, it will be considered part of the prescriptive approach, and subsequently where it is required beyond that. As in one of the sessions, we were also discussing in terms of these aspects that if it is beyond design element. I'm saying one of the session where I was asking Mr. Antip Kumar, I was asking about a situation where if it is for a soft story effect. So if that is not clearly stated in the portal, how are you doing it? So same in that case again, the high-rise committee is evaluating along with a set of engineers from CIT BUH also, where they collectively work towards understanding on performance approach. So typically it is gone through a performance approach, and as a element of understanding, it works as a regular structure, but it is filled with concrete and steel, which is on the outer periphery. We don't have reinforcement in this. We have shear studs, which is acting for composite action. That's how it is. Right?
I would like.
Hello, I would like to add regarding your question that IS 16700 is coming with a new second part of the code which will cover the composite structures, and I think we will cover something for CFT in that. So it is already drafted, and very soon this second part come. As present IS 16700 covers only the reinforced concrete buildings.
To project manager of Phoenix Group. So in your presentation you mentioned that in your some of the projects you maintain sustainability, which is approximately 98% of sustainability, and many of the IT clients prefer to adopt the sustainable buildings for their operations. So like how do you maintain competitive edge over the other contractors? Like obviously if you are using steel prepared from sustainable means rather than charcoal furnaces, it would obviously cost more. And so my question is like how do you maintain profits, and like how do you compete with other contractors in that sustainability case?
How it happens is that typically when the client has to take it on lease, so they compare all the competition in the market. What are the various options available in the market to take it on lease? So assume that there are 3 or 4 competitors in the one particular micro market. There is a checklist that they follow, and they give a weightage and numbers are like, to weightage to each aspect of it. And most of those international companies give highest weightage to how environmentally compliant the building is. So today we are considering buildings which are platinum rated. Recently we completed the building with what we had shown. That is a platinum rated building, right? And very soon we are trying to get into the more like a net zero type of thing. Yes, while we have a passion to go towards environmentally compliant and sustainable usage of sustainable material and stuff, it also helps us to position us, because weightage to our building will be much better on that particular segment, right? So that's how we differentiate and benefits us. And with regard to the whole life cycle of the product, I think Ellen can answer much better.
So a part of the presentation what we mentioned, 98%, that's a recyclability of the material. So sustainability comes in the overall holistic approach of a material. The material, when it is produced, there's an amount of carbon which gets in as an embodied, but the material, once it is developed and it is got into its shape, then the recyclability stage, it is not going to consume much of its energy. So that's where the steel comes out clear winner in terms of its sustainability. And sustainability is not only alone by choosing the material. By choosing that material, it has various other advantages, as Mr. Jagdish has mentioned. In terms of the resource, we require less resource, we require less water, we require less time. So basically, everything is getting optimized. So we are not wasting energy, we are not wasting resource, we are not wasting money. But the only thing is, anything which is good comes at a cost. So we need to find out how minimal time we can achieve these constructions. So that's when time is essence of the overall aspect. So that's how it is.
You may ask some question about your career path, etc. also as a young professional. I'm sure you must have many doubts about such kind of things as well. As a career institution in university.
My question is to Gautam sir and maybe to the Jay sir, being an architect. So I'm working on origami things. So you talked about a lot about facades. So when we're talking about sound insulation or maybe the heat insulation. So there has been certain cases in probably I guess Dubai or somewhere in UAE. So they are using the origami to fold and unfold whenever there is sun, it folds, you get the shadow. What are the challenges in implementing these kind of projects, in particularly in facades, and maybe when I talk about to Jay sir. So when you design some of the buildings, now most of the tall buildings are not very, they look fancy because they are taller. The people are looking this is something different, but when we talk about I think if origami has been implemented somewhere in architecture, so have you been into such kind of project in the past, or have you ever think of this kind of project as an architect? Yeah.
So interesting, and you are actually, I think India is still starting to see, at least its scale, it is still starting to see value in terms of design intervention. So remember what happens is that the project you are talking about actually is in Abu Dhabi, where they've used sort of these movable facade panels that shade. Obviously, it is incredibly expensive, and budget is not necessarily a constraint in a place like that. And we're seeing that we're doing some work in Saudi Arabia, and similar, the fact is that, with places like that, cost is really not the point. The idea is to create something iconic. That still, it takes some time to be able to do something like that at that scale, because you'll have smaller project, private villas, where you'll have the opportunity to experiment. We just completed a project where we did one of the largest 3D printed installations and things like that. So when you are at smaller scale, you have the ability to do things like this. Still, on a larger scale, it's difficult to find those kind of, I would call clientele. And similarly, we're doing some work in, we're doing this large 5-star hotel in Mauritius. Again, because it's low rise, because it is spread out, we have the opportunity of doing a more design intervention thing. Remember, what happens is that, let's look at 1 million square feet or 1.5 million square foot. And if you're doing something that's custom, multiplying that for that amount of area obviously is hugely expensive. So hopefully it will happen soon. There's definitely no shortage of creativity or ability in this country to be able to deliver that. But I think we've not yet seen it. Hopefully we'll see it soon.
Okay, whatever I'm going to say for the next 2 minutes, take it with a pinch of salt and don't take it too hard. 3 big issues with that. Number 1 is cost. I literally sit on a graveyard of concepts, projects which got designed or conceived but didn't get implemented because it was way too costly. Number two is anything that moves requires maintenance. Moving parts into a building call for maintenance. They tend to break down, they require replacement, so they need to be as simple as possible. That's, I think Dubai Finance, Abu Dhabi Finance Corporation or something was behind that building, so again, money is no problem. So, one breaks, you replace it within 5 minutes of it breaking. And then I think the bigger challenge is towards responsibility. Now, if you're shading a building dynamically, great. Nobody likes static buildings. If your building is doing something in slow motion, it's more interesting to look at. But end of the day, how much energy are you consuming to make that concept work versus how much energy are you saving? So I think that's the larger question. But having said that, don't hold yourself from designing fun stuff. Sure, there are ways to make it work.
Particularly, my question was to like how difficult it is to get it practically, aspects behind this thing.
You answered the question, aspects behind this thing, largest one being cost. Like Jay said, at an ownership level, if I'm having my villa and I want something to move on my building, I might be willing to invest. At a large scale, when you're talking a 200, 300, 400 meter building, at that scale, it becomes a very sensitive decision to take because you're literally getting married to that solution for the following 40 years, 50 years, and you're literally committing yourself to maintaining that solution. Not a lot of people have the courage to do it, to be honest.
I'll just add, by the thought of Jean Nouvel has done a museum in Paris where he took the idea of camera obscura and actually did it very sensitively, did it at a reasonable cost. The last time I was there, it did not work particularly well. It clearly didn't get maintained, but there are ways of doing it. Again, I think you're incredibly lucky to be on a campus where you have buildings like you do. This is not very common in India. And I think that hopefully creates a sensitivity towards the value of design and the value of architecture while you design, while you learn engineering. I think there is huge value and there is huge potential to be gained by doing things like this. Hopefully, slowly, we're able to marry the two and able to find the right client as well as the right solution to be able to come up with that.
What do you expect as an architect? Like, what do you expect when you design kind of not design probably in this way, but like when you design something very different, like what do you expect from like new structure engineering to be like what do you expect from it? Project as well as like a 36
Hopefully a good diff, but again, I think every architect is different. So I'm more, I personally am more strategic. So I find something done for the sake of being done. I find it a little bit like mental masturbation. Like, it's just there. Typically, I would like a reason why we're looking to do something. And once you have that, it's easier to hopefully rope in other people to see that, to see the reason behind it. I think to me, design is in an interesting, it's solving a problem creatively sometimes, or which is why I find that if you're actually solving a problem, then it's not just design for design's sake. It works better, it uses better. There's something beyond just the facade in one way. And I think have been very lucky where if you find like-minded people, where of course there will be a push and pull between any engineer and any architect, but I think that's really healthy, because because you want to push yourself, right? You want from both points of view, where you typically, and it's not only engineer and architect, typically a clientele also, and it's really a team that recognizes obviously there are constraints to work with and what is the best possible solution that kind of comes out, keeping all of those constraints in mind. I think it's really healthy. I don't see any concern with it, and I think it pushes us to do better. Yeah, that's what I just.
While there are challenges, I was just mentioning, yes, there are challenges, but you can find out solution that is really something what you should give a try. Never leave out. So that is one thing. What the other thing which I just wanted to add is, yes, origami, one is about moving facade, one which is in motion, the other thing is a parametric design. So parametric design certainly gets into something where you minimize the material usage and optimize in terms of the overall efficiency. I think that is the way which is actually the facades are getting towards, and if you can look into that and give a solution, definitely that becomes more adaptable and it becomes a solution. As what he says, and as any architect says, form follows function. So that's how it gets in. Yeah.
Sir, I have a question for all of you. Actually, we have many services in India, like we have Zomato and many other entrepreneurship services which the companies are providing. So, with context to that, I would like to ask you all, so what is the most sought service that you are expecting in your respective areas? Like a company, maybe a company like Phoenix or an architect. So what is the most sought service that you are expecting from around yours, from your surroundings?
As part of the value chain?
Yes, sir.
Seeing business ideas, I reckon, right?
It's other way we should ask. So, on a lighter note, I always at least internally say that what is Phoenix? Is it a construction company, developer? My answer to my team is that we are only a marketing company. The reason being, we know to identify the location, we know to create a product, what is sellable, we know how to brand it, we know how to sell it, right? What we don't want to get into is construction, because that is not our forte. Our value creation happens in identifying the right location, arranging the money, getting the stakeholders together and everything. If I have to do construction, if that is my core value creation as a part of my larger strategy, then I'll be having 200 employees, workers in my part of my payroll. I'll be having 50 engineers doing the construction management in-house. The value creation in construction management happens maybe at 10% of the project cost. But the value creation that happens by various other means is much higher. So my pain point today is that to get the supply chain in place, that means it's a combination of a general contractor. Today, for me, the biggest challenge I face is to find a general contractor who understand what the general contracting mean. They all sign a contract, they call it as I'm a general contractor, give me 10% on all the trades. When it comes to delivery of services, they all look different direction. Delays happens, cost overrun happens, and at the end of the day, everything comes on a developer. We are the last in the queue, so everything falls on us. A larger, yes, a general contractor, what we need as a country today to grow, a general contractor truly understand what it takes to deliver a building. And part of that, a project management companies, who are in a position to understand and manage the stakeholders. If you ask me one thing which is very, very critical for a successful project delivery is stakeholders management. And that is one thing which is not normally understood by, and you guys at some point of time in your career you will come across this. Stakeholders management is going to be the important thing when it comes to delivery. And because you are dealing with bunch of different organization having diverse culture, having multiple goals, coming to a project which is short-term in nature, and everybody has got a different role to play, and everybody is dependent on each other in terms of trade. Look at the level of complexity that is there in a building construction. So, who is the master of the orchestra? Imagine that every person who is there are typically a 25 to 30 trade involved in a building construction. Okay, each person deal it as a instrument. So there has to be one person who has to coordinate, the master of the orchestra, and that's a project manager. Right? That particular service, many of the companies like us, we outsource. There is a huge shortage in terms of talent. Even the project manager understands exactly what it takes to deliver a project. I hope I have answered.
So your question is what to follow. So to my mind, best thing is follow your passion. What interests you more, that is most important. What you are comfortable with, what is your ideas, where you want to work. Because nobody can work in the field which he is not passionate about. You have to be passionate about your work, whatever you do. Yeah, please.
Most of the students nowadays, they have passion towards many things, but now as a student, they are not able to explore the opportunities which are there in the commercial places or where generally people work, because they don't have idea about what is going on in the outside world.
So I will give you a few examples. Like one of the IITian, he controls 60 to 80% of the world market. What he does is he is engaged in doing press for any pressurized thing. He has just a dhakkan to that. So if there is a pressurized container, so you have to put something which can hold the pressure. And he is so expertise, he is having so much expertise in that, so he is controlling almost 60 to 80% of the world market. So it's just a passion. Some IITian has built Chayos, which is working all over the market. So only sky is the limit. India will have lot of opportunities in the coming year. When we passed out, the opportunity was nothing compared to you people. You are having a lot of opportunities, and Indian economy is growing. We are poised to become the third largest economy of the world. So I don't think you bright minds have anything to fear. Only you have to believe in yourself, and you can go to any height.
Sorry, I just wanted to add one thing. Everybody applauded. I thought maybe it was the wrong time to add one more. I think two things I want to add. One is obviously follow your passion and just want to do as something that you would love to do for the next 20-30 years, because passions can be very frivolous, right? Like you like something now and then maybe a week later you like something else. That's one. And second thing you asked, your original question was what is the most sought after service? I would change that to what is the most sought after skill. One is fine analytical skill is something that's really missing in kids that come to us, seeking work. And second is common sense. It's become so uncommon now, like people come two and two together. So I think those are two things I would really love to see when somebody has a conversation.
So actually, good question. Something that direct is because we've been actually looking for people to fill these roles and have been unable to find this. So this might directly get to somewhere. All of the points, by the way, before are very true. So I'll say something what I feel will happen in the next 5 years. 80% of where our office spends its man hours will be replaced by AI in the next 5 years. What I mean is that while the fruition of the project may or may not, from schematic to GFC, there are companies today that are able to take 10-story, 12-story buildings and generate an entire set in the space of minutes. Now, what we would otherwise take 6 months, 1 year, etc. to do, there is no doubt we will still want someone to check everything manually, etc. But where I would have spent a team of 6 people working over 6 months, I may spend one person checking over 50 days. I constantly find that people still haven't recognized how much of an impact this technology will have. We feel that's similar to what is kind of going on. And knowing a little bit more about what's going on at the back end, I can tell you that this will be a game changer. So we've actually started a cell in the office that specifically is looking at AI and sort of design. And we've been looking for freshers, experienced people, anyone it's a paid position, looking for people who are interested in just, one, there are tools out there, how does one best use them? Second, how do we actually start building on tools? Because the really good thing about where the market is today is that there's a whole bunch of open source stuff. It's about finding the right thing and applying it to the right place, which is the most difficult thing to do, by the way. And here again, scale is actually a friend, because the Googles of the world will not be able to move at the speed of someone who's sitting and just recognizing the need and the ability of something to and marrying the two. It's something which if I was in college today, I possibly would have moved quite differently than how my life has actually turned out. And I keep on sort of telling, just because we've not been able to find the right talent. And the funny thing is, we're not even looking for people who really know AI. We're just looking for people who have that mental ability, like what Gautam said, of looking at something, analyzing it, oh, ye yahan ho sakta hai, ye yahan nahi ho sakta hai. Understanding it to that level, because you don't really need to code anymore. So I think all the things are right, the passion, all of that stuff, but I think if you are able to get into that field, I believe that the first trillionaire in this world will come from this.
Good.
Again, that is regarding tubular sections. So tubular sections. So when what I feel the major challenge for these tubular sections is that, like sir was mentioning in his presentation, that almost around 100 lifts of these things are happening at the side. So again, these walls and these sections are very thin, right? So they can have this dents or kind of a damage happening on the sections. So is there any criteria to actually or the tolerance limits for you to actually check whether these damages are permissible, or is that kind of thing happening, or like what's your comments on that?
Verticality and damages are not so
it is not alone on CFT columns, including beams or any members part of the steel structure. So verticality has to be a major. So it becomes a mandate part of QA QC that we ensure that the lifting is done rightly, even right stocking is done rightly, lifting is done rightly, position is done rightly, and it is fixed in place. So the entire TQA is that has to be maintained. There is no choice on that. See, because in steel structure, the amount of accuracy what it gets in is 1 mm. So the moment you have a problem, there won't be another element which is fixing in, and it gets in time motion study. So if one gets delayed, everything gets a cascading effect. So that is where he was mentioning that that approach is slightly risky, but it is not impossible. All what you have to do is nail that process in that way that it is sequenced rightly, and you get the quality what is required.
verticality has to be maintained. But when it comes to the tubular sections, along with the verticality, you may have the local damage also. For example, there's a dent or
There are codal provisions which are there, and codes are there which refers in terms of tolerances. I don't remember to tell you exactly what it gets in, but if it is a higher then it will be case specific which need to be evaluated.
But normally this is, for example, your columns are typically in 12 mm and 16 mm.
Even 25 mm and
the beams do, sometimes you use 8 mm, 6 mm.
Yeah.
That is because very light. In the transportation, recently in one of the projects so happened, and they transported, they forgot to put another insertion hole between the beams. Sulfite, due to sulfite itself. What will happen? When you won't place the beam, secondary beam, the holes won't match. So even before we raise a quality issue, the guy took it back saying that, buddy, I will spend a lot of time and effort and money to recognize the site, rather I will take it back and bring it.
Because for a 30-story building, 50-story building, 50th floor, you lift it position in place and you realize it is not working, then that's going to be a big challenge. So
where the issue, I will tell you where the issue happens. When you put those insert plates tied to the rebar, pour the concrete, many times what happens, the insert plate location is misaligned. When you try to connect your beam to the insert plate, to the fin plate, that's where the misalignment happens. That is where you have to do in situ rectification. Then you have to build a plate, put a patch plate over there, or cut some of those fin plates to align. That's where the maximum time it takes rectification. Am I right?
yes. And that is the reason we go with a insert plate and then weld at site with those sections for connection at times, because that becomes much easy to align. If it is put in the concrete, even if it is going to be 10-15 mm difference, it is going to be a trouble.
It could be all direction. It could be x-axis,
y-axis.
It could be tilt also.
Yeah.
Okay, looks like students are too shy or too proud, I don't know. Generally, through my interactions with students, I see that the motivation to stay in the field of civil engineering is declining. Majority of them, and we can say that it is an unfortunate condition, but whatever it is that they take civil engineering or structural engineering as because they didn't have any other option, so they ended up here because maybe the rank or whatever, So, but some of them are passionate about this field, and those who are passionate want to pursue a career, but then societal pressures for various reasons. So, maybe from your experience or your experience as a people who are managing these large companies, managing many human resources, what would you suggest how they can find the niche for their own expertise and make a career, maybe? So, those points you have already mentioned, that you have to be passionate about the area that you are working in. Of course, that's given. But still, in the long term, if you are constantly looking at your peers, at your batchmates who are at different places, how do you keep yourself motivated, and how do you find that niche? How did you cope, and what is your opinion? Maybe some of you may want to add. This is not a question pointed to anybody in particular.
Yeah, you add something?
You want to add something? Yeah.
So sir said already declining, but the ones who want to be in the field. So first thing is the packages we get here. That is the first thing. That is the reason I see. But from the developer's perspective, or all of you are from all sides of this industry. So why is it the pays are quite less? If you see the computer science engineers, he's earning at least 20-30 LPA, and if you compare the MNCs are offering 6 LPA and 7 LPA and they are hiring 1 or 2 guys from that to the master's student. And again, that is the one thing, and how would that student will look for a long term, when he enters structural engineering. Obviously there's a experience thing which comes, but if somebody I want to
be a consultant, independent consultant, maybe. Yeah.
Sorry. Hello. Yeah. So, hello. What Anil ji has said is correct, and this problem is intrinsic with construction industry itself. If you see the other fields like computer science you mentioned, or industries, so they are more organized. Unfortunately, the developers are not that organized. We are having a very few companies who are well organized, and like L&T and others, but we don't have that much organized fields in the developer. The reason are there are intrinsic problems with the developers also, and those also because regulations are changing. This is a very high capital intensive market, and there are a lot of attrition. Somebody is coming good at and then they may not be doing that well. So that's one of the problem. Perhaps the industry has not matured enough to give the students that opportunity. That's the one problem. We have to accept it, and I think it will improve with now the next generation developers which I am working with. So now I am working with, so all my clients are 32 to 35 years of age, and I find more maturity in those people compared to the developers with whom I was working previously. So I'm an optimist, and I feel that the things will change. The coming people will be more stabilized. This industry will stabilize, and perhaps better pay structures and better thing will come to that. Other than that, for contracting side, what Jagdish Babu was telling is very correct. We have very less choice. Most of the people, we have not developed anything. If you see the Lytton from Australia is coming, we are only having an L&T, Saporji, like one or two companies. And giving the scale of construction happening in India, at least we should have 15 to 20 such companies. So that is a field which is open to work, and that's if those things develop, then there will be a lot of opportunities. Yeah, not only more contractors. There are many contractors, but there has to be a vision to become a very good general contracting company, very good company, not just doing as the others are doing. So excellence in that field is needed.
See, one mistake we do normally is that we, make it the education and profession a standardized one. If I am a, engineer by education, I have done, say, BTech, civil, that means I have to do in construction site, not required. Right? Somebody have a passion to do that, they can do. Imagine a civil engineer working in a construction site vis-a-vis a civil engineer working as a client relationship in an IT company, okay, which is providing a specialized services on beam, say. Okay, imagine a civil engineer working in a R&D company which is providing specialized services on design mix, right? You mean to say that all the civil engineers in all these organizations will be paid similar? No. Right? So what happens is that the value creation, the payment to an employee based on how much of value he is adding to the system, right? And the person who will excel in a particular job is not based on that particular position is giving salary, I will excel over there. No, nobody can excel there. The fundamental that thing is required is that you need to have that passion, right? The learning comes from the passion. You will take that extra effort to learn more, and that's how you become successful. You will be always observant what's happening around the world. You will be up to date in terms of the knowledge, right? That's how you become successful. So you put both the things together. Somebody could be very passionate about being physically at site, making construction. And trust me, those guys, maybe initial 2-3 years, they may draw less salary. Because of the sheer passion of delivering buildings, they will be in 3 to 5 years time, will become a project manager and keep growing in the thing. So don't ever get disheartened by looking few failure cases, because those, I would say, a misfit of a person who doesn't want to be there in the position or job is compelled to because of social or various competitions. Let's not do it.
With majority of the times when I don't know if everybody is from a civil engineering background or there's anyone from other background. Is everyone from civil engineering background? Okay. Oh, wonderful. Good diversity. Pardon?
Actually, I have one question for you, sir. I'm from economic background. What is
Probably I'll cut your question. If not, then we'll have the question subsequently. So what I'm saying is, majority of the times, even there was an instance where NAC, National Academy of Construction, where in one of the instances I happened to be there, and I was interacting with students to understand what is their aspirations to be in and understanding. The general understanding, as Mr. Jabbi was mentioning, that everybody is looking at excelling in civil engineering or getting into civil engineering. But as he also mentioned, there's about 30 fields which are available, or 30 such packages which are available in civil or for a construction project to complete, like facade, like plumbing, like fireproofing. These are areas people have not explored. Those are the areas where ideally people should see an opportunity, and everybody has interest, so you can choose based on the interest you can get into it. How many people will be interested upfront if I say, will you take a role in plumbing? Well, any of you guys will be looking into plumbing as a field of industry? I'm just asking a question, just how many people will be interested to get into plumbing industry for your career growth? Any hands up? You know how much business it is giving in, and I bet even the IT guys cannot compete with the kind of business what they are doing it. A guy who is marketing for a region gets at least twice the salary of an IT company guy who probably 10-15 years of an experience can't beat that. So those are the niche fields which are available where people don't explore. Fireproofing, and the best example, I think you can say better onto it. We don't have the right technical expression. Waterproofing. Today that's actually a problem statement what we have. We don't get a technical guys to understand the waterproofing subject. The holistic understanding about the subject is what it is missing. And you have to see opportunity across. Water meters, right? Water meters, there's a company by name VGOT. So just run through that. He is again a Madras IITian. So he has come up with a solution of IIT, which is VGOT is nothing but water, electricity, gas, and some of the telephone and all. So basically, he has come up with a solution with LoRa technology, where with the low frequency technology, he is metering across the water consumption across the buildings, and we have opted that in our buildings, and it is working out absolutely with a minimal cost on it on a subscription basis. We are able to get the metering, and data is mine. So the amount of data what it is getting out of it is giving absolutely a way forward for sustainability. So how many such solutions you guys are thinking? So I'm just giving a thought here, saying that there are so many fields. Explore the overall construction right from its start, right from your dam-proof course to that of waterproofing. You have 30 fields which are there to choose. So it's about you to choose and then take it. That's what happens.
So what I found is there is symbiotic relation between electronics electronics and civil engineering, sir. I heard a term called structural health monitoring system. What are the sensors which we could build in future so that even this scope for electronics and civil background, sir?
So there is a company by name Sion, person. That's a startup. They've already got the sensors which they are placing in concrete to understand temperature, to understand the performance and stresses, and to evaluate both predictive and post concreting measures. So there are companies. It's an area which has already started with. That's a vast area to explore still, because there is no end solution that somebody has got with a solution and there's a dot for it. So you can explore. That's one of the key areas where you can explore. Electronics, while we were going with Mr. Like we were going your lab. So at that point of time we were saying, so he was showing me a small component which is being collected. I'm saying that small component of equipment which is collecting the data, but creation of that takes longer time, right? So there are a lot of areas data capturing is required. We today don't have data. So what in our organization we have done in the last 2 years within the organization is to collect the historical data. So for last 7 years, whatever the projects we have done, we try to put all the data into one repository so that we can compare, put to intelligence to understand what can be used for the future projects. So the data, how to get it, is something what can be thought about.
Check out Sidewalk Labs, an entire township in Toronto. This is again a different division of Google, where the entire idea was in essence data collection through sensors. They did some incredible work with, see, one is the sensors and what they pick up, and second is analyzing that data for what it can actually bring back in terms of intelligence. There's some incredible work already done. Like he said, it's a completely open field and there's a lot of potential there, worth spending some time on.
Thank you all the panelists for a wonderful discussion, and thank you all of you for all your questions. I hope we'll go back from this session a little bit wiser than we came in. So now it's time. It's almost the conclusion of this seminar. So first and foremost important thing today is to thank all the speakers who have taken time out and to be here with us. So we have from CTBUH side, we have a few mementos to be given to them. So let me first go by the same order in which the speakers presented. So let me first offer it to Amitabh ji. Mr. Jay Shah. Thank you for your time. Mr. Gautam Bhasin. Also, I think Mr. Nambika Srinivas Rao is not here. Yeah. So, Acha, I am this one. Okay, so you collect it on his behalf. So this is for the sponsors. And Rajiv. Thank you for your support.
So, thank have the nerve of steel.
Yeah. Hello. This seminar would not have happened without the support of the host of as IIT Hyderabad and my special thanks to Anil ji. Only this seminar could happen due to him. He has taken great efforts for that. So an appreciation from CTBUH I will give him a memento.
Yasin, can you correct some of the departments also? Yasin will correct it.
I would also like to thank head of the department, Professor B. Munawar Bhasa, Civil Engineering, for permitting and hosting this seminar as a Civil Engineering Department head. So in his absence, Mr. Yasin will
All right, so before we finally conclude the session, the most important duty now is to thank all those who have come together to put this show, and I hope it has been helpful, it has been valuable to all the participants. To start with, I think the biggest thank goes to CTBUH, especially Amitabh ji and his entire team to take this initiative. In fact, I mean, it was their initiative. We should start encouraging interactions with universities and colleges, and they took the in. In fact, initially there was hardly any support to us. We had no idea how to proceed. They encouraged us, and then we took the call and we went ahead with the program. Thank you, sir. Thank you to CTBUH. And also, the most important contribution also came from the sponsors. So with the help of the two sponsors, we were able to put up a good show. So thank you, sir, for your support. I would be amiss if I don't mention the amazing work that is done by all the volunteers, starting with Yasin ji, of course, and of course Ravi Teja has helped significantly, and all the student volunteers, Vijay attendant. So you have all interacted with Fayaz and Prem. I suppose you have had some interaction. Prithvi has helped also as a volunteer. Ira, in the morning she was here. They helped as volunteers. So I wish to thank all of them, including all the attendants, Vijay. Okay, and of course the department supported us. Department gave us the permission and also all the logistical support. Thanks to the department and the institute, and of course all the speakers for taking time out. I'm sure you have better things to do, but your career and your professional life, for taking out time from there to interact with the students, give back to some college, it's really appreciable. I wish to thank all of you. Thank you. So with this we conclude the session. Now we just need to move things back. Maybe tomorrow morning, but both that area has to be cleaned also.